Welcome you all on the occasion of National Workshop Day on Applied Mathematics and Career Opportunities, organized jointly by Ferguson College, Autonomous Pune, and Shikshan Maharshi Guruvarya R.G. Shinde Mahavidyalaya, Paranda. Today is National Mathematics Day. We celebrate National Mathematics Day on the birth anniversary of great Indian mathematician Srinivas Ramanujan, who worked in number theory. I take this opportunity to introduce Principal Dr. R.J. Pardeshi, sir. Sir is shouldering the responsibility of principalship for more than a decade. Sir completed his PhD from Savitribai Phule Pune University in 1991 in geology. He has completed 2 research projects and have more than 10 research publications in reputed journals. During his tenure of principalship, Ferguson College received A grade with 3.26 and 3.62 CGPA in NAC with 4-point scale. Also, Ferguson College received very good NRF ranking in last 4 years. Ferguson College received status of college with potential excellence and college with excellence during his tenure. He is member of many prestigious committees at national level like NAC core team member of 12th plan HRD Government of India, various UGC committees and many more. With this brief introduction, I request Principal Dr. Ravindra Singh Pardeshi to inaugurate today's national workshop and guide the participants. Over to you, sir. Oh, sir. Yes.
Good evening.
Yes, sir.
Audible now?
Yes, sir. Yes, very much.
Good morning, Saudam.
Good morning.
Thank
Good
you,
morning.
Manish.
Yes, sir.
Good morning. Thank you, Manish. Especially, I welcome Professor Katre, and today we celebrate the mathematics, and therefore this kind of organization is helpful, and that too we are now in the Paranda. Therefore, we are and we are very happy to have this collaboration, because as of college, which we have a long legacy of excellence in the higher education, we have been extending all possible help with other colleges, whether they're from different parts of country and also especially in Maharashtra. So whether it is NAC, DBT, or even autonomy, we have been trying to do it, and we are very happy to say that yes, couple of colleges where we could extend this as a college, of course. And then having experience of our teachers, they are working hard and they're trying to put in all efforts. We are very happy that the college has been doing well, and as now the college, new college which has joined, like that, we continue our efforts. And on the occasion of this particular time, that is a Mathematics Day, it is very happy note that we are conducting this workshop, and students from different parts, especially from Paranda, they will also be benefited. Of course, online technology has given us a way ahead, and therefore we can conduct such programs on a large scale. So today, the day-long workshop which is there, where there are experts coming from mathematics, especially Katre sir, we know, who has been a great mathematician. My colleague, Dr. Vinay Acharya, like Bhaskaracharya, through Bhaskaracharya Pratishthan also, as a college, we try to conduct many programs, and each teacher is trying to put in all possible efforts. So I must say that as a mathematics, of course, Ferguson College also was known for this kind of a thing. Wrangler Paransper, Wrangler Mahajani, who were there, and Lokmanya Tilak himself was also one of the founders of Ferguson College. So what I'm trying to put in all across is that, yes, this kind of an effort, we shall definitely go ahead and we shall try and expand more. And even we had one international program that is with the Max Muller Bhavan, mathematics that you can learn, I mean, by yourself. So that was more than 5,000 students from schools and even veterans who visited, and that was a great program. So these kind of activities are always conducted, and Dr. Vinay Achar, who is senior, Manish has now taken over. Dr. Manish, he is also doing it. Every teacher, of course, as I said, and therefore we look forward, Savale Madam, that as two colleges we can work together and we can try to extend the best possible things to our stakeholders, especially the students. So on this note, I wish all the best for this workshop and conclude. Thank you.
Thank you, sir. Now I would like to Dr. Nalawade sir to introduce Principal Madam, and thank you. Over to you, sir. Nalawade sir, तुम्ही mute आहात.
Am I audible now?
Yes, yes, please.
I am very happy to introduce our principal, Dr. Srimati Deepa Dinesh Savale Madam. She is our principal since last 8 years, and our college has been bloomed nothing like before in these 8 years. I am proud to say this as for our principal. She has a qualification MA, MEd with PhD. She has a long teaching experience of 35 years. She has published total 59 research papers, and along with that, 9 candidates have been awarded PhD degree under the guidance of respected Dr. Deepa Savale Madam, and 5 MPhil students are also awarded the degree. She has completed 3 major research projects under various schemes, and she has visited Bangkok once for attending a conference and presenting her paper over there. A wide range of awards she has awarded with 35 prestigious awards by various NGOs and government agencies. She is also a member of various university committees. She was a chairman of BOS in the subject of history, and she has actively participated in in social work, social societies. With this brief biodata, I would like to welcome our principal, Dr. Deepa Savale Madam, to say a few words on the occasion of inaugural of this national workshop. Over to Dr. Savale Madam.
Good morning to all. It gives me immense pleasure to organize the one-day national workshop on applied mathematics and career opportunities. We collaborate this activity with the renowned Ferguson College, Pune. I welcome Principal of Ferguson College, Professor R.G. Pardeshi, Emeritus Professor S.A. Katre, Dr. R.D. Holkar, Dr. H.R. Bhapkar, Dr. M.S. Wavre, and all the faculty and students. We celebrate this 22nd December 2021 as 34th birth anniversary of Srinivasa Ramanujan as National Mathematics Day. We know that Ramanujan had not taken any formal training in mathematics. Still, his passion about mathematics made substantial contributions to mathematical analysis, number theory, infinite series, and continued fractions. He solved the problems which were considered unsolvable at that time. During this short life of 33 years, Ramanujan compiled nearly 3,900 results. This workshop is intended to inspire all the young and enthusiastic students from various colleges in Maharashtra to look up mathematics as a career. I convey my best wishes to the workshop through this Zoom meeting. Thank you very much.
Thank you, madam.
Thank you, madam. Over to Manish.
Now I would like to call Rushkesh sir to introduce Katre sir. Over to you, Rushkesh sir.
Yeah. Manish sir, am I audible?
Yes, yes, sir, very much.
Yeah. Good morning, all. It is my pleasure to introduce Professor S.A. Katre, who is currently the Lokmanya Tilak Chair Professor at the Department of Mathematics, Savitribai Phule, Pune University. Professor Katre has a long career in mathematics spread over 4 decades. He has completed his BSc, MSc from the University of Pune and his MPhil and PhD from Punjab University under the supervision of Professor A.R. Rajwade in cyclotomic numbers, which is a part of number theory. He has held several important positions in mathematics at the University of Pune as a reader, professor, and the head of department. His research has led to numerous publications in national and international journals, and he has also contributed to a number of students to complete their MPhil and PhD programs. He has been one of the pioneers to start the Mathematics Olympiad activity in the Pune region, having led the team in Argentina. He is also the custodian of Bhaskara Pratishthan Pune, which is a premier institute promoting mathematics across all levels in India. And I would like to mention that today's talk is the subject of the topic that he will be discussing will really appeal to undergraduate students, because he is going to talk on polynomials, which is one of the very basic topics discussed at high school and even at postgraduate level. So I will request Professor Katre to start the talk. Thank you, sir.
Unmute yourself, Manish. Unmute yourself.
Katre sir is joining. Just a minute. Let me. Hello, Katre sir. Am I audible?
Yes, I am. Yes, you are audible.
Sir. Rushkesh sir have given introduction of yours.
Okay.
We can.
Good morning, sir.
Good morning. Yes, right.
Pardeshi sir is there.
Yes.
Principal Pardeshi sir and Principal Savule madam is also there.
Yes, nice to meet you, sir. Madam.
Good morning, sir.
Good morning. Yes.
Sir, I request you to start your sessions.
Yes, thank you very much. So it is a good opportunity for me to talk to the participants of this workshop on the occasion of the National Mathematics Day, which is the birthday of Ramanujan. And in fact, last year we had Smriti Shatabdi of Ramanujan, and it was therefore many lectures were organized. And as we know, this is the occasion of National Mathematics Day. In 2012, it was declared this day, 22nd of December, was declared as National Mathematics Day. So we have the opportunity of discussing some mathematics on this occasion. And Ramanujan certainly is one of the foremost mathematicians of the country, and he has given research jobs to many people. Many mathematicians worked on the work of Ramanujan, extended further, gave proofs of various conjectures which Ramanujan made, and therefore it is a very nice thing for us, very matter of pride for Indians. So on this occasion, I would like to talk to you about some interpolation formulae. And so my topic is Hermite interpolation formula. Usually we know the Lagrange's interpolation formula, which we study. Oh, I think I have to start the presentation.
Okay, Deshmukh sir, please make Katre sir host or co-host so that he can share the
I
screen.
think I may be able to share, yeah, screen.
So no problem, sir.
I have
Deshmukh
clicked
sir.
on that. Can you share? Can you see my presentation now?
Yes,
All right.
Yes,
Okay.
yes, sir,
yes.
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 Okay, very nice. So one-day national workshop and Hermite interpolation formula is my topic today. And so basic idea is that we know equations of lines. And if you are given 2 points, x0, y0, and x1, y1, then what is the equation of the line passing through these points?
Sir,
So-
if we can see the screen, but if
Yeah.
you are doing something else, we cannot see because we can see just this topic Hermite interpolation formula.
Actually, yeah, I am writing actually on a new page.
Sir, then you share everything, sir. Share your screen, then it will.
Oh, I see. New share.
If you are sharing white screen, then
Huh.
you need to,
Sir, yes, yes, we can see it. now.
and
can
now
see
it is
that.
visible.
Huh.
Yes, sir.
Yeah, probably I go to the next page, then again it becomes invisible. Let us see when I complete this page, what happens. Let us see.
Sir, share full screen. Share full screen. Everything that will be on desktop will
On the top, yeah.
share full screen.
Yeah, actually, I did that only essentially, but anyway, let me do it again. I have to go out and come, but let me see, maybe I will finish this page and let us see. If you
Yeah.
cannot see the next one, then.
Yes, sir,
let me
yes.
do that.
Yes, sir.
So y minus y0 equal to slope into x minus x0. So slope is y1 minus y0 upon x1 minus x0 into x minus x0. So this is the equation of the line passing through 2 points x0, y0 and x1, y1. So this is the first interpolation problem that we do at the high school level or beginning of college level, or let us say 11th and 12th standard, we study equations of lines. The another thing that we also study is y equal to mx plus c. That is one form of the equation of the line, and another form is y minus y0 is equal to slope. Slope is again, we can just write it as m, slope m into x minus x0. So this is the point slope form as we know. The point is x0, y0, and the slope is m. This we can write as y equal to fx. And fx is y0 plus m into x minus x0. So this right hand side is a function fx, and the derivative f dash x, if you calculate, that is nothing but this m, that is the slope. So these are two forms. One is 2-point form and another is point slope form. And our idea is to generalize these two forms when we have additional information. So one additional information can be that you are given more points on the curve y equal to fx. So y equal to fx is a form that we are interested in, where fx is a polynomial in x. And we want the following condition: f of x0, that should be equal to y0. That means the point x0, y0 is on this curve. Similarly, f of x1 equal to y1 and f of x n. Okay, so now here we have how many conditions? N plus 1 conditions that we have. And we want to find a curve y equal to fx but the simplest curve is a polynomial in X. So we can think of a polynomial in X. Polynomial in X. Now, what is the type of this polynomial? What is the degree of this polynomial? So because we can have n+1 conditions, usually a polynomial we can write as a0 plus a1x plus a2x square, etc. And if we are given n+1 conditions, then the appropriate thing would be to consider a polynomial like this: a0 plus a1x plus etc. plus an x raised to n. In this, we see that there are n+1 unknowns, a0, a1, etc., an. There is no point in taking more variables like an+1, x raised to n+1, and so on, because we have only n+1 conditions with us, and determining more variables will be, this is the minimum thing that is to be done here. So, okay, I will now take next page, blank document, and now can you see this?
Yes, sir, we can see this.
You can see, very good, thank you.
Yes, yes.
So now, how will you find out this curve y equal to a0 x, a0 plus a1x plus a2x square, and so on, plus an x raised to n. We want to find out this curve, and what we are given is yi is equal to f of xi, where fx is our polynomial on the right hand side. So this is the problem that we have with us, and how to find out these AIs. So one method for this is, as some of you know, you have to put x equal to xi and the value should be yi. So yi is equal to a0 plus a1 xi plus and so on plus an xi raised to n. This is what we have, and these equations that we have, these are n+1 equations, 0 less than equal to I less than equal to n. Okay, so these are linear equations. We can consider these equations as linear equations, a0, a1, etc., an. In the are the variables, and coefficients are 1, xi, etc. So to solve this system of linear equations, what we do is, our usual method is Cramer's rule, and Cramer's rule tells us you find out this determinant delta is equal to 1 x0, etc., x0 raised to n, 1 x1, etc., x1 raised to n, and finally 1 xn, etc., xn raised to n. So this is n+1 by n+1 determinant, and we can prove that this value of the determinant is product of xi minus xj I bigger than j. So whenever xi are x0, x1, etc., they are all different, this determinant is non-zero. So this is not equal to 0 for distinct xi. For distinct xi, this is not equal to 0. And now we can find out delta I. They are determinants obtained determinants. How do you obtain these determinants? In the previous determinant that we have, delta obtained by replacing the ith column Now ith column means 0 less than equal to I less than equal to n, like that we should consider. So first column is 1, 0th column, then first column is x0, x1, second column is like that, and nth column. So by the column of constants, by the column of constants. So the Cramer's rule then tells us that the value of AI is going to be delta I upon delta. So we have solved this interpolation problem using determinants. So you see that we have obtained a curve y equal to a0 plus a1x plus etc. plus an x raised to n, where this curve passes through xi yi, or in other words, yi is equal to f of xi. And the coefficients a0, a1, etc. are obtained by the determinantal formula delta I upon delta. And this is a unique solution to this system of equations. That is because the determinant, this is a system of linear equations in n+1 variables. N+1 equations are there, and the determinant is not equal to 0. So we get a unique solution. So this is the method of determinants, in which we have to know that this Vandermonde determinant, its value, Vandermonde determinant, this is non-zero because it is product of xi minus xj, I bigger than j. You will see here first row minus second row. If you do this calculation, then you will see x0 minus x1 is a factor. And similarly, xi minus xj is a factor. And the determinant is divisible by the product of xi minus xj. And then you can compare degrees. You will see that there is only one constant there. Delta is constant times product of xi minus xj by comparison of degrees. And that constant is 1. You can check that. So that is how the determinant is evaluated. Vandermonde determinant is product xi minus xj, I bigger than j, and it is not equal to 0. So we have solved this interpolation problem. But the difficulty in this is that it is complicated to find out these high order determinants, because only this delta is known to us. But what about this delta I? Delta I, they are determinants obtained by replacing the ith column by the column of constants. That is, column of constants means those y0, y1, etc., yn on the left hand side. You have these constants. So that is complicated. You know that high order determinants are very difficult to calculate. Of course, we can do Gauss elimination and such things to do the calculations. Some computational methods are there. Therefore, some kind of different formula is required, and that was obtained by Lagrange. So what is that formula? Let us see. If you look at this 2-point case, y minus y0 is equal to y1 minus y0 upon x1 minus x0 into x minus x0. So this is the starting point for this thing. And we can see that this can be written in the following form: y0 into x minus x1 upon x0 minus x1 plus y1 into x minus x0 upon x1 minus x0. So this is a different way of looking at the previous equation. There is a kind of symmetry in this. And if you look at these polynomials, the numerator is x minus x1, for example, and denominator is a constant x0 minus x1. So this is a polynomial of degree 1. Now there is a speciality of this polynomial. The speciality is if you put x equal to x1, then the first polynomial becomes 0. On the contrary, if you put x equal to x0, then this becomes x0 minus x1 upon x0 minus x1. So it will be 1. Similarly, the second polynomial has the property that if you put x equal to x0, it is 0. But at x equal to x1, the value of the polynomial is 1. So these are some nice polynomials. They have some peculiar properties. And because of these properties, it is easy to see that the value of the polynomial at x0 is y0, because at x0 what happens, y0 into 1 plus y1 into 0. So at x0 it becomes y0. Similarly, at x1 what happens, y0 into 0 plus y1 into 1. So it is easy to see that the value is like this. So to generalize this thing for more points, generalize to n plus 1 points. That means you want that this curve passes through these n plus 1 points. And such a curve, we want y equal to a0 plus and so on. We want like this. However, we do not write it in this form, get it in this form. The previous answer was polynomial which is written in powers of x. But we use a different kind of strategy, which is explained by this example for the straight line. Y equal to y0 into some polynomial. Let us call it as capital L0. And so I can write y equal to y0 L0 plus y1 L1. I'm calling it as L0 L1 because Lagrange was probably the first to write the equation in this nice form, which we will see. And we study also in the numerical analysis course. So what Lagrange proposed was get a polynomial which is 1 at xi and 0 at other points. 0 at other points. And this polynomial, let us call it Lix. Lix. And by this kind of experience, usually when you want to solve for large values of n, you should see what happens for n equal to 0, n equal to 1, n equal to 2, etc. and get some idea from that, and then you can write. So the similar idea one can use, and Lagrange, what Lagrange did, he considered x minus x0 because it should be 0 at values other than xi. So he wrote this thing in the numerator, x minus xi he omitted, and x minus xn. This is a polynomial which is vanishing at all xj other than xi. So j not equal to I then vanishes, but j equal to xi, now it has some value. But you want to make the value to be equal to 1 at xi. So what we do, if you put x equal to xi in the numerator, it becomes xi minus x0, etc. That you put in the denominator. Of course, xi minus xi is not there I am putting a cap there. Cap means that term is absent, and xi minus xn. Xi minus xn. So now you see that this polynomial satisfies our requirement that at xi, the value is 1. And at xj, all other values of x, so x0, x1, etc., but not xi. So at other values of x, the value of the polynomial is 1. And then one gets the Lagrange's formula. So what is the Lagrange's formula? Let us see. So this formula is y equal to, now as before, y0 L0 x plus etc. plus yn ln x. Now put x equal to x0, what happens? L0 x0, that is 1. But L1 at x0, L2 at x0, Ln at x0, all of them are 0. Because x minus x0 is the numerator for them. Therefore, only y0 remains. So y equal to y0 at x equal to x0 is satisfied. Similarly, y equal to y1 at x equal to x1. Because Lix, these are, we can call Lix as Lagrange polynomials. And how many of these are there? These are n plus 1 polynomials. They are of degree, each of them is of degree n. Each of these Lagrange polynomials is of degree n. So this combination y0 L0 plus y1 L1 etc. is what? Is a polynomial of degree. Will the degree be n? All the Lix are of degree n. But when you do combination, the degree can drop out, because sometimes, you know, the coefficient, when you expand and see what happens, coefficient of x raised to n may be 0 also sometimes. So the polynomial can be of degree less than n. So this is a polynomial, right hand side is a polynomial of degree less than equal to n. So y equal to fx. This is a polynomial of degree less than equal to n. Please note, it may not be of exact degree n, although Lix are of degree n. Note that this polynomial is uniquely determined. Uniquely determined. And that is because the Lix, they form a basis. Lix form a basis of the vector space of polynomials of degree less than equal to n. Okay. If you call Vn to be the vector space of polynomials of degree less than equal to n, then what is the dimension of this vector space? The dimension is n plus 1, isn't it? Because constant plus something into x plus something into x square, etc. So dimension is 1x, x square, etc. x raised to n is a basis, and this is a vector space of dimension. Actually, dimension of this vector space is n plus 1. And here, can you see that these are linearly independent? Because you can take 0 equal to a combination. 0 equal to, let us say, b0 L0 x plus etc. plus bn ln x. These Lix depend on xi. So put x equal to x naught, what happens? If you put x equal to x naught, then L naught x, that becomes 1. Okay, L naught x naught is equal to 1, and others are 0 at x naught. That means 0 equal to b naught into 1. That means b naught is 0. Similarly, you put x equal to xi. Similarly, you put x equal to xi. And that gives you bi equal to 0, 0 less than equal to I less than equal to n. So these LIX are linearly independent, and they form a basis of the vector space of polynomials of degree less than equal to n. And therefore, that also tells you that any polynomial is uniquely determined. Any polynomial of degree less than equal to n is uniquely summation ai li. Okay, it is uniquely summation ai li. It is uniquely a combination. And the coefficients are obtained. Ai are what? They are just values of the polynomial at xi. So we can determine the coefficients easily. Okay. So this is about Lagrange polynomial. We have seen that Lagrange polynomials, they form a basis of the vector space of polynomials of degree less than or equal to n. And we get the interpolation formula. So these Lagrange polynomials are very important, and the expression is also somewhat better for calculation as compared to the previous formula, which was in terms of the determinants. As we know, evaluation of determinants is more costly. Sometimes we feel that this Lagrange interpolation formula is very difficult, but you know that it is much simpler than the formula in terms of determinants. The advantage of determinantal formula is that you get the answer in terms of powers of x directly, right? Directly in terms of powers of x, you get the answer. Here, you don't get the answer in terms of powers of x directly. If you want that answer, then you have to simplify these LIX and get that. So that is the difference between these two formulae that we have seen. Now let us go to the Hermite interpolation formula. So what is Hermite interpolation formula? As I mentioned at the beginning, we have y equal to y naught plus slope into x minus x naught. So here, this is fx, and fx has the property that f of x naught is y naught, means it is passing through x naught y naught, and the derivative f dash at x naught is equal to m. So with this information, we are getting this equation. So the question is, as I mentioned earlier, that find a polynomial fx such that f of xi is equal to yi. Of course, yi are distinct, 0 less than equal to I less than equal to n. And that is, this is one condition. And the second condition is f dash xi. This is new condition now. Should be, let us say, yi dash. That the derivative at xi is yi dash. Again, 0 less than equal to I less than equal to n. And so this is a polynomial we want to find out. We get a curve y equal to fx. If you find such a polynomial, we get a curve y equal to fx. What is the property of this curve? Property of this curve is it passes through xi y. In the language of this curve, we will say it passes through xi y, and it has slope dy by dx is y dash. Slope is y dash. So that will be generalization of this point slope form for the straight line. Okay. Now, how many conditions are there? In the previous problem, there were n+1 conditions, isn't it? In the previous problem. These are already here. Fxi equal to yi, 0 less than equal to I less than equal to n. In addition, we have derivative conditions. How many? So they are also n+1. So we have total number of conditions 2n+2. Now, if you want to find a polynomial y equal to fx, then what is the degree of fx? So curve is y equal to fx, polynomial is fx. It is of the form a0 plus a1x, etc. What is the degree that we should try for this polynomial? And the degree is, because 2n+2 conditions are there, we should have, you might have guessed already, a 2n+1 x raised to 2n+1, isn't it? Because degree is 2n+1 and one constant is there, a0 plus a0, a1, etc., a 2n+1. That becomes 2n+2 unknowns, and 2n+1 equations are conditions are there. So as before, we can solve it using determinant method. So what we should do? F of xi equal to yi. So you have already some conditions. Y0 equal to a0 plus a1 x0 plus etc. That is the first condition. Similarly, y1 equal to a0 plus a1 x1 etc. And similarly, yn equal to a0 plus a1 xn plus etc. So these are n+1 equations that we are getting. So what is this equation? Let me just write yi equal to a0 plus a1 xi plus and so on plus a2n plus 1 xi raised to 2n plus 1. These are n+1 equations. Okay. So now similarly we have, so let us write down the system of equations. Yi equal to a0 plus a1 xi plus and so on plus xi 2n plus 1. This is the first set of equations. I is now varying from 0 to n, not 2n plus 1. And now, what is the second set of equations? Second set of equations is from derivative, and derivative is yi dash. Now, a0 plus a1x, derivative of a0 is 0. Derivative of a1 x1 means a1x, that is just a1. So we have a1 xi plus a2 xi square. A2 x square, what is derivative? 2 times 8, that is xi, equal to xi. And finally, 2n plus 1, 2n plus 1, a 2n plus 1, xi raised to 2n, isn't it? Xi raised to 2n. So there is dot 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 in between. And these are again n plus 1 conditions. Now this is a system of linear equations. How many linear equations? 2n plus 2. In how many unknowns? 2n plus 2 unknowns. We have a system of linear equations in so many 2n plus 2 unknowns. And these are same number of linear equations. So we try to solve it by using determinant method. Delta is equal to what determinant? So coefficient we should look at 1, x0, etc. x0 raised to 2n plus 1. 1 xn, etc. xn raised to 2n plus 1. Then 0. Now look at yi dash equal to a1 xi, etc. Coefficient of a0 is 0. Then I think there is a derivative of a1x. So I can write only a1 times 1 there. Maybe let me write a1 times 1. Derivative of a1x is just a1. So please make that correction if you have written down. So here I should write just 1. Then I should write 2 times xi. Then 3 times xi square, etc. And finally 2n plus 1 times xi raised to 2n. And now this I will go from 0 to n. So the first I can just write like this, or I can for demonstration write x0 here, and similarly last thing will be 0, 1, 2, xn and so on. 2n plus 1 xn raised to 2n. This is the determinant. And then you can similarly write delta I by replacing the ith column by the column of constants. Constants are y0 to yn, say yi, y0 to yn and y0 dash to yn dash. So this is a column of length 2n plus 2. And delta I upon delta, this is the value of ai for 0 less than equal to I less than equal to 2n plus 1. And we have solved it essentially. Only what is delta? Is it 0 or non-zero? That is the question. Now in the previous case, Lagrange case, we know it is van der Waals determinant and it is non-zero. Now this also is going to be non-zero, and I would request you to attempt to show that delta is non-zero or try to find the value of delta. There are some possibilities like, for example, first row minus second row, that will give you x0 minus x1 as factor. Then here this 0, 1, 2, x0, etc. There also that minus the following row, if you subtract Rn n plus second row and n plus third row, subtract, then you will see x0 minus x1 is one more factor there. So x0 minus x1 square is going to be a factor for this delta. Okay. So try to see if you can find the value of this delta. It is not easily available. That much I can tell you. So please but certainly I have demonstrated to you that product of x minus x1 square, such things. That means in general, I would say this is a factor xi minus xj product I bigger than j. This is square now instead of first power. That is a factor of this. And then anything remaining, so think about this problem. But anyway, you can solve it by this method. This determinant is going to be non-zero. So this is determinant method for getting the interpolation formula. And as we see, determinant method is certainly complicated for actual evaluation. Now, Hermite thought that this is not a good method, determinant method. Of course, it is there, method is there. But can we follow Lagrange and do something? So what Lagrange did, he found out polynomials LIX. What are these polynomials? These are, let me write it again, product x minus xj, j not equal to I, and I is varying from 0 to n, divided by product xi minus xj, j not equal to I. Okay, I is varying from 0 to n. So LIX satisfies the property that LIXi is equal to 1 and j not equal to I. So can you somehow follow this idea? And that's what Hermite did. So Hermite wrote the following formula. H2n plus 1 x is equal to. So what is the requirement? As I wrote earlier, you want a polynomial passing through xi yi. First condition. Second condition, derivative slope at xi should be yi dash, slope or derivative. So we want y equal to fx. This is the kind of polynomial, and yi dash is equal to f dash at xi. This is the second condition. Okay. First condition is yi equal to f of xi. Second condition is yi dash equal to f dash at xi. And then the curve will be y equal to fx. Okay. So what is this h2n plus 1x? Derivative, I mean, the polynomial should be of degree up to 2n plus 1. So we write it as h2n plus 1x. We have the vector space of polynomials of degree less than equal to 2n plus 1. And our polynomial is in this vector space. So we write it as in the form summation. So h2n plus 1x is equal to summation yi into h n I x, I equal to 0 to n plus summation I equal to 0 to n yi dash h hat n comma I x. So on the right hand side, that n means the number of conditions is varying from 0 to, I mean, the 0 to n. F of xi is equal to yi, I equal to 0 to n. So you are summing from 0 to n. And there are two summations. First summation is it uses yi, values of the function at xi. Second summation uses yi dash, which are the derivatives. Now, if you want to follow Lagrange, what you should do? Lix, we know the properties. Similarly, what should HNIX satisfy? The ith polynomial, it should have the value of, so let us write down the requirements of Hn and Hn hat. Of course, ith polynomial. So this polynomial at x equal to xi is yi. Okay. And 0 elsewhere. And 0 elsewhere. Zero elsewhere. Similarly, what about derivatives? You should note that you require derivatives equal to 0 at all xi. This polynomial HNIX, then it will be useful, remember. At xi the value is yi, at xj the value is 0, but derivative should be 0 everywhere or all xj. Similarly, what about HNI x cap here? I am putting cap here. What should be the property of this? It has derivative at xi is yi dash, but derivative equal to 0 elsewhere. Derivative is 0 elsewhere, and not only that, values 0 at all xj. Value of h cap should be 0 at all xj. Now, this is kind of, we are following the method of Lagrange and getting this. Now, is the requirement satisfied? H2n plus 1x, look at that. H2n plus 1. Evaluate H2n plus 1 at x equal to xi. Then HNIX is 0 at other xj, and at xi the value of HNI is 1. Therefore, H2n plus 1x will be yi, because the cap, h cap, it has 0 value at all xi. H cap has 0 value at all xi. Therefore, H2n plus 1 x at x equal to xi will be only yi. Now, what about derivative? What about derivative? See, first polynomial HNI has derivative 0 at xi for all xi. So that part will become 0 at all xi. Now, the second polynomial h cap, it has derivative 1 at xi. Therefore, h dash to n plus 1 at xi will be equal to yi dash. Okay. So this satisfies our requirement. So the last thing is to find out these HNIX and H cap NIX. How to find out these? That is the question. And answer given, now it is a kind of creative thing. One can write down some initial formula, think about it, what it will be. And let us first give H cap NIX. The idea is to use the Lagrange polynomials. And the Lagrange polynomial Li is 0 at xj for j not equal to I. But suppose you want derivative also to be 0, what we should do? So simple idea is, if I take x square, then at x equal to 0, it is 0. But its derivative is 2x. That is also 0 at x equal to 0, isn't it? If I take just x, then derivative becomes equal to 1. But if I take x square, then the derivative also becomes 0 and the value also becomes 0 at x equal to 0. Similarly, if I take x minus I square, okay, x minus something, x minus say alpha square, at x equal to alpha, the value is 0. Derivative is 2 times x minus alpha. So derivative is also 0 at x equal to alpha. So this is a very simple idea that was used by Hermite. So Hermite said you use Lagrange polynomial, but take square of that. Take the square of the Lagrange polynomial. So L Ni x square. Okay. H cap Ni x is equal to L Ni square x. Now, what are our requirements? You take the derivative of this. Derivative is going to be 0 at, so derivative equal to 0 at x equal to xj, because L square has factor x minus xj square, isn't it? J not equal to I. At x equal to xi, is the derivative equal to 1? That is the question. Okay. Also, is this 0 at all xj? That is another question. All these L square, Lni square x, I am putting n also here. Earlier we called only Li, but now I am calling Lni. It is 0 at all xj, j not equal to I. So at x equal to I also you want it to be 0, but it is not 0 right now. So what you should do? You should put a factor x minus xi here. Okay. We should put additional factor because we want it to be 0 at xi. Okay. Now, now this polynomial becomes 0 at all the points, and its derivative becomes 0 at xj, j not equal to I. But what about the derivative at x equal to I? It should be 1, isn't it? Derivative at x equal to xi should be 1. We want it to be 1. Is it 1? Please check. Is it 1? See, it is a product of two things. First function into second function. So x minus xi into derivative of the second thing and derivative of x minus xi, which is 1, multiplied by L square at xi. But what is Lxi? Lxi is 1, therefore L square xi is also 1. And x minus xi into derivative of L square Li square x at x equal to xi. But you know, whatever the derivative is, this x minus xi makes it 0. at xi, x minus xi is 0. So this second term becomes 0. Therefore, the derivative at x equal to xi is exactly 1. That is what we wanted. So h cap ni is equal to 1. The derivative of that is equal to 1 at x equal to xi, and the value is 0 everywhere, all xi. Means x0, x1, etc., xn, all of them. At all these points, the value of h cap is equal to 0. So the second polynomial satisfies our requirement. Now what is the first polynomial? h-nix. h-nix. So h-nix, now similar tries you can give and make modification, right? We started with L square and multiplied by x minus xy. Similarly, you can try it, and I will give you the final answer: 1 minus 2 times x minus xi L dash at xi, L dash ni at xi multiplied by this square L n I x. This is Lagrange polynomial, but we do square of that. See this, I demonstrate that the squares were appearing there, isn't it, in the determinant formula also. And the square has the advantage that derivative becomes 0. So we multiply by Lagrange polynomial square of that, and then the whatever is in the square bracket is just adjustment. Okay, so it is please write down, those who are interested, please write down this formula and show that HNI is satisfying the required properties. That means it should have derivative 0 everywhere. Derivative 0 everywhere. And value of this at x equal to xi should be 1, which is easy to see. Value of this at x equal to xi, because second term becomes 0, 1 only into L square at xi, which is 1. So value of HNI at xi should be 1. At xi, the value should be 0. And derivatives all 0. So these are two Lagrange interpolation, Hermite interpolation polynomials, h and h cap. And using them, the formula h2n plus 1 was obtained. So this is essentially the end of my talk. But I would like to give you a simplified formula here, which is a better formula than this, which is I didn't say anywhere, but this is the formula: fx equal to summation I equal to 0 to n yi plus beta I into x minus xi li square. Li means lni, depending upon n also, where lix are Lagrange polynomials and beta I is yi dash minus 2 times yi summation 1 upon xi minus xj, j not equal to I. So from the previous formula, you can also prove this formula, which does not involve derivative of Lagrange polynomial. Remember, see that HNI involves derivative L dash, but if you simplify it further, then you will get this formula that I have mentioned. So this is what I have derived using a different method, but it can be obtained from this formula also by finding this L dash xi. So please try that. Both these things you may try. So with this, I stop here. If you have any questions, that's fine. Otherwise, we stop here. Yeah. Thank you.
Thank you, sir. I would like to thank Professor S.A. Katre. He have given very good insight how Hermite used Lagrange's polynomial and came up with his interpolation method. Thank you very much, sir, for giving such a wonderful lecture.
Thank you.
Any questions from students? You can, all questions are welcome.
So I just want to mention that you can also generalize this and find formulae, but they will be more and more complicated as we see. But this Lagrange and Lagrange is anyway for interpolation, but the derivative formula, that is Hermite's formula, is useful in, for example, designing of curves, fonts designing, etc. You want to draw a specific curve, then if you know the derivatives, that is slopes and points through which the curve passes, then you can draw the curve. So that way it is useful in computer aided geometric design. So this formula is useful in that sense for CAGD. Yeah, that is one application of this Hermite formula especially. Yeah. Okay, so thank you all. I will now stop because I have another lecture also after
Yes.
this. So thank you very much.
Thank you, sir. Now I request my colleague, Professor Nanasaheb Fatangre, to introduce Professor Rohit Holkar. Over to you, sir.
Okay, good morning again. Our next speaker is Dr. Rohit Holkar. Rohit did his BSc from Ferguson College, M Math from ISI Bangalore, for which he got prestigious Erasmus Mundus Fellowship. So he did his PhD from Göttingen University, Germany. He also did his postdoctorate from two places, Brazil and IISER Pune. Now currently he is working as a faculty at IISER Bhopal. So he also wrote articles in Marathi on mathematics. His videos are available on YouTube, titled माझ्या आजीची गोधडी. So he's versatile in not only mathematics, in other fields also. So I welcome and request Rohit to start his talk. Thank you.
Sir, unmute yourself. Rohit, sir.
Sorry, yeah, I forgot. Yeah. So I said, thank you for the nice and pleasant introduction. Should I start sharing my screen now?
Yes, sir.
Just a moment.
Deshmukh sir, please make him co-host so that he can share.
Sorry. So is my screen visible?
Yes, yes, sir. Very much.
Okay, and it seems I'm also on.
Yeah, it will be nice if you do it landscape. It's right now in portrait mode.
Okay, okay, all right.
Yeah, that's much better.
Okay, yeah, thank you. So I'll start the talk now. My so I'm going to talk how to diagonalize symmetric matrices. This is one of the basic techniques of linear algebra. One of the basic results in linear algebra is how it is considered. So in fact, the standard belief is that a good linear algebra course should end with diagonalizability of symmetric or self-adjoint matrices, if you're talking about complex vector spaces. And it should also discuss linear functionals and the Ritz theorem, at least for finite dimensional cases. During my times, this was the end of our course in linear algebra. Recently, I saw that it has been a while when this theorem has been taken out of the syllabus. So I thought it's a good venture again to interlude into this theorem and then tell the present students a nice theorem from mathematics. The proof that I have chosen today to present is in Lang's book. This is an interesting proof. The reason I chose is that this proof uses vector spaces. It has to use it anyways, but it also uses calculus. And it's a very nice proof which has a very beautiful geometry behind it. Moreover, this is basically the idea. So there is a big class of theorems wherein people ask the question that when is a matrix diagonalizable? In general, when you go to infinite dimensional vector spaces, similar questions are asked. When is a certain operator diagonalizable? And the story begins, if one goes in a theoretical order, then the story begins at the symmetric matrices. And this very technique, which Lang discusses in this proof, is used pretty much for most of the proof. So it's also a very basic technique. It's a very fundamental idea. So that is about this theorem, why one wants to discuss it. So before I start revising certain topics, I have a question to audience that do you want me to speak completely in English, or you also want me to take a hope to doodle in Marathi also? So is completely a talk in completely English fine with everyone, or
It is fine.
okay, good.
Fine in English.
So whatever you feel better
Yeah.
way to communicate, you can use that, sir.
Okay, all right. I'm anyways comfortable with any of these languages, even the mixture. I was just thinking about the audience. Anyway, so if you have any doubts or if you have any questions, then please feel free to interrupt me and ask the question. Good. So to start with, these are the topics which we need to discuss. So especially for the third year BSc student, it's a quick revision of your linear algebra course. And what do we need? So first is that when it comes to vector spaces, I would expect that you know the rank nullity theorem. If you don't, then recall that the rank nullity theorem states that if you have finite dimensional vector spaces W and V, and you have a linear operator T from V to W, then the dimension, can someone tell me what should be fill in the blanks? So can someone tell me what comes in this blank here? Hello?
Anyone from participants, please?
W.
Right. The dimension of the source space here is nothing but the dimension of kernel of this linear mapping and dimension of its image. That's the rank nullity theorem. It's a very useful theorem and a characteristic for finite dimensional spaces, linear mappings over finite dimensional spaces. Secondly, I would like to recall definition of perp of a subset. So just to go there, recall. So throughout the talk, I'll fix V as a vector space over the real numbers, and it's finite dimensional. So if its dimension is n is a natural number, which is not 0. Moreover, very frequently, I shall keep identifying V with Rn if dimension of V is n. Okay. So in general, if I have such a vector space and I take a subset X in V, can you tell me what is the definition of X perp? This is collection of what?
It is a subset of other than the X
Mhm.
elements. It is a subset of other than X element. All subsets are there.
So you mean to say that XPerp is V minus X as a set?
Yes. Or
No, that's not.
it
how
is a
it is.
collection of all subsets.
No, that's not how it is. See, there is a sign that you have been seeing since high school. What does this sign mean? You have seen this,
Perpendicular.
right? Now that's a hint. Now can you tell me the definition?
Yeah. It is the product of these vectors should be 0 with those vector which has the
So you take all the vectors in V such that
which are
these vectors are perpendicular.
vector
to X.
product is 0.
Right. And what is the meaning that Y is perpendicular to X? Then it is given in terms of the inner product on Rn. So Rn
Yeah.
is an inner product space. It's also a non-linear space. So this is collection of all vectors Y such that this vector Y is perpendicular to every vector in X.
Yes.
So by perpendicular, we mean that the inner product is 0. So recall that this is the Euclidean inner product. Inner product Yx is nothing but sigma Yi Xi, wherein I consider each vector Y as Y1, Y2, Yn by identifying it using a basis, and X is considered as X1, X2, Xn. Right. So XPerp for a set, okay, so I'm saying X is a set in V, is refined as this V. Then note that XPerp is not empty. Why? Can you tell me immediately that there is a vector in XPerp?
Yes, sir. It is a subset and it is non-empty.
See, XPerp
It
is
must-
non-empty. I start with the non-empty subset. That is fine. But why is XPerp non-empty? Can you
Because
immediately-
zero vector is always perpendicular to everything.
Right, because zero vector is always perpendicular to any other vector. So zero vector is in XPerp. So moreover, if you can recall, it must have been in your course that XPerp is actually a subspace. Is a vector
Yes.
space of R. Subspace of, V. So I shall take it as a fact. The next question is, what is XPerp? See, XPerp is a subspace, therefore it is a subset. What is its perp? So the answer is that this is
X, I think.
Good.
X,
So if you say that this
again.
is X, yeah. If you say this is X, then recall I said it's a set. Let's look at an example. I think of
Perpendicular to perpendicular. Like that.
Right. But I look at R2. See,
Yeah.
first of all, notice that XPerp is a vector space by this theorem that you just stated.
Minus X, that means
Therefore,
is direction
perp-
changes, right?
Yeah, that's fine. But the first point is that this result says that XPerp is a vector subspace. Therefore, the perp of XPerp also has to be a subspace. That's the first thing. So think about your answer. For example, if I start with a vector in R2,
Yeah.
just a vector. So my X is singleton vector V bar. What is the perp of V bar? It's the collection of all vectors which are
Perpendicular to
which is nothing
perpendicular to X.
which is nothing but the line which is perpendicular to V bar.
Yes, sir.
This is Yeah, this is basic geometry. And now what is perp of this perp? This is going to be collection of all vectors which are perpendicular to this set, to the line.
If we are considering R square, then it is V and minus V also.
Is it just V and minus V others?
It is a set of all vectors which are generated by linear combination of X.
Exactly. A linear combination of V bar.
Yes,
so,
sir, yes.
So the point is, I look at this red line and then I look at all the vectors which are perpendicular to this red line. Therefore, this also is a straight line again. And the straight line is now determined by V bar I started with, the non-zero vector. So it's basically the straight line passing through V bar. Similarly, in R3, if I take a one-dimensional, if I take a single non-zero vector, then its perp is going to be what? It's going to be the plane which is perpendicular to the given vector V bar.
Yeah.
So it's V bar perp. On the other hand, if I take this plane and I look at the perp of this plane, then that will be the line passing through this vector, because the dimension of R3 is 3. That follows from a basic geometry. So with these examples in hand, the answer to this question is, now you should prove it analytically using the definition of perp, is that if I take a subset and take a perp twice, then this is nothing but the vector space generated by the set X. In particular, if X bar itself happens to be a subspace, then what you said in the beginning is right. Its perp taken twice is X itself, because the subspace which X generates is X itself. And these earlier examples also tell us that if I start with a subspace X of V, then so this is a subspace. I take this subspace, I look at its perp, and if I take the sum of these two, then this is the original space V. This should follow by the rank nullity. In general, the sum of a subspace and its perp is actually a direct sum, which is isomorphic to the original space. So a vector subspace and its perp, they decompose V into two orthogonal complements, is how it is, how we say that this and this are perpendicular to each other. Good. So that is all we need about the perp. And then we should also go back to symmetric matrices. So you see, when matrices are taught, like as a student, I always wondered why so many type of matrices, and especially this interesting matrix, which looks very innocent, symmetric matrix. What is a symmetric matrix? So if I have a matrix Aij, when do we say that A is symmetric?
Xi is equal to Xj. I is equal to J.
I don't have any X. I know what you're saying. I'm just
Aij equal Ji.
Right. That's a symmetric matrix. In other words, if I take A transpose, then A transpose is same as A. Now, check that if I take two vectors X and Y, and suppose I apply this matrix A on Y, which is identified as Rn. Do you know what symmetric matrix does to this inner product? Hello?
Yes, sir, you are audible.
Okay, sorry. Yeah, so can you tell me what does the symmetric matrix do to this inner product? It does a very interesting thing. So do you know this, that in general, if I have inner product of X with AY, then this is same as inner product of A transpose X with Y. So it's a standard identity, but A transpose being same as A, it just means that
Itself.
that if I take inner product of X with AY, then A can apply on X and still have inner product with Y, both the quantities are same. So this innocent looking identity is a very fundamental identity which has a geometric meaning. In exams, we used to do this. You have some important identity, you write it VVIMP because it's going to come in exam. So this identity will play a role in towards the end of the talk. I'll ask you for its geometric meaning by then, but let's see. So once we have a symmetric matrix, then yeah, that's what it means. And after symmetric matrices, I would like you to recall the following ideas about matrices, linear mappings, and eigenvalues. First is the relation between matrices and linear mappings, and secondly, eigenvalues, eigenvectors, and eigenspaces. So going back to matrices, if I take a matrix A, which is an n by n matrix, then you know that A induces a map from Rn to Rn, a linear mapping. What is this mapping? If I take a vector x, what is this function? So do you know this function?
A times x.
Right, it's A times x. The point is A is an n by n matrix, and you take a vector in Rn and consider it as a vertical vector, x1, x2, xn. So this is an n by 1 vector. And when I take product of these two vectors, the resultant is an n by 1 vector, which is again seen as something which is inside Rn. So this is a function. Every matrix induces a linear function from Rn to Rn by taking product with vertical vectors. Conversely, every linear mapping of Rn gives rise to a matrix An. How? If I have a linear mapping T from Rn to Rn, then this is given by multiplication by this matrix. What you do is take T evaluated at E1. E1 is 1, 0, 0, 0. Take T evaluated at E2 and write them as vertical vectors. And T, E1, E2, En. Then this is an n by n matrix. Each of its column is a vertical n column. And an interesting calculation, but very easy calculation to do is that T of x is nothing but multiplication by this matrix. So that's how matrices and linear transformations are assigned with each other. Now, among these linear transformations, there are very nice looking linear transformations. Which are they? So consider again an n by n matrix and think of it acting as a linear transformation. Then see that Ax, the simplest transformation is that Ax is equal to 0. Everything goes to 0 for all x's. But in this transformation, there is nothing to study. In this linear mapping, there is nothing to study. The next interesting and simplest mapping is that Ax is equal to lambda times x, where lambda is some real number. And this happens for all x's. This is called as scaling by lambda. Why? If lambda is greater than 1, what is the geometry of this map? What does this do to a vector? Say lambda is 2.
It doubles its image.
It takes a vector and it doubles what?
Image, it means X.
See, a vector has
2x.
two things. A vector can be characterized by two things, its length and its angle. So what does it double?
Length.
Right.
Angles remain same.
Exactly. So if in general lambda is greater than 1, then this linear transformation increases length of the vector by a factor lambda. Whereas if lambda is less than 1,
It shrinks.
Exactly. It shrinks the vector. So it's a very fundamental transformation. And after this basic transformation comes a slightly complicated way of this transformation. Namely, you think that your vector space is spanned by vectors v1, v2, vn. They are spanned by these vectors. And on each of these vectors, this matrix behaves as a scaling. Lambda vi, a times vi is lambda I times vi, where you fix lambda 1, lambda 2, lambda n in R. So this is the next level of linear mappings, which are slightly complicated, but again, they are theoretically pretty much like this one. And this is basically the idea wherein we come across what is an eigenvalue. What is an eigenvalue and eigenvector? So definition is that for a matrix A, a real number lambda is an eigenvalue of A if AX is equal to lambda x for some non-zero vector in V. So in general, the goal of today's talk is that to show that if A is symmetric matrix, then there is a basis of the vector space V, which consists of eigenvalues, eigenvectors. So this vector is called as an eigenvector corresponding to eigenvalue lambda. So now you can see that this theorem is important because it says that given any symmetric matrix, it acts by scaling certain vectors, and that's it. And because these vectors generate the whole space V, the whole operator can be seen as just scaling operator in general, or the whole matrix linear mapping can be seen as scaling on different things. So it's a very simple kind of transformation. And it's non-trivial because it says that it happens for every symmetric matrix. So it's a big class.
Yes.
Yeah. So good. So that is about eigenvalues. I won't discuss eigenspaces as of now. And the next part that we need is from analysis. There are two famous theorems which we already know. So first famous theorem is the following. So let me ask again a question. So the prerequisite from calculus course, it's actually a calculus course, is that suppose if I have a function 0 to 1 on 0 to 1 taking values in R, which is continuous. What can you say about this function? There are many theorems regarding such functions. Can you tell me some of these theorems? Then I'll choose a theorem that I want.
Lagrange's mean value theorem.
Right, it has mean value theorem.
Cauchy's mean value. It depends on it.
Yeah, but in general, you can assign mean value theorems, which will say that if a value x and a value y in R are taken, So there is a point A such that FA is X, and there is a point B such that FB is Y. Then given any number Z between X and Y, there is a point C in the interval
F dash
that
X.
Z is taken by C. That's the mean value.
F dash Z is equal to C. Right.
Right. Oh, I'm about continuous function. I haven't yet shifted to differentiability. Something else? Okay, is it possible that you have a continuous function on closed interval 0 to 1 and the function is unbounded?
Yes. Log
On 0 to
Log.
1, closed interval 0 to 1. A continuous function on closed interval to 0 to 1 that is unbounded. Can you give me such an example?
log X. Sorry.
Is
1 upon X.
what is 1 upon 0?
1 upon 0 is not defined, but
Right.
it goes to infinite.
No, so that's the point. So see, when you say a function is defined on 0 to 1, it means it takes all values at 0 to 1. At every point it is defined. That's the point.
There exists no such function.
Why?
Bonzolo-Weierstrass theorem.
Which one?
Bonzolo-Weierstrass theorem, which says
Both are- Yeah. So that's a theorem that this will say that f is always a bounded function. Moreover, f takes minimum and maximum value. Which means that there are points x and y in your domain such that there is the minimum value fx, there is the maximum value fy, and all other values of the function lie between these two. So f is bounded. See, there are two parts. One is that f is bounded, which means that maximum, the infimum and supremum of range of m exist. But the next part also says that these values are taken. So there are actually 2 points in the domain at which the minimum is obtained, and at the other point the maximum is obtained. So that's the non-trivial part of it. In general, this theorem has a general version, namely, let K be a subset of Rn, which is closed and bounded. If you have had course of metric spaces, then this is nothing but a compact set. If you know the word compact. So you take a compact subset of Rns. In other words, closed and bounded subset of Rn. If f is a function from K to R, then f satisfies this theorem. It means that f is a bounded function and its minimum and maximum values are taken on K. It's a very fundamental theorem. It's very important also. And the next theorem is that, suppose the next result that we need is that f is also differentiable. So you can use differentiability of either functions on the real line, or you can talk about differentiability on Rn. If f is differentiable, and then let's stick to the one-dimensional case. So f is from AB to R. Then you know that the derivative of f at extremum is if z happens to be an extremum, then what is the derivative of f at the extremum? By extremum, I mean a maximum or a minimum. If z is a maximum,
0.
right, then this is one of the basic results, that the derivative at extremum is 0. That's it. So this is all we need to discuss the theorem. That's it. So I have very briefly and quickly refreshed your memories. And then we go to the main result. So before we proceed, let me define certain continuous and differentiable functions associated with the matrix. So here onwards, we'll fix an n by n real matrix. And we shall think this matrix as acting by linear mapping from Rn to Rn. Or if you want to think in abstract case, then think of it as acting from V to V. Again by multiplication by vectors. See, if I look at this particular picture, A acting by multiplication from Rn to Rn. This is where we discuss some linear algebra thing. But Rn is also metric space, or Rn has the Euclidean metric. Therefore, I can talk about the continuity of this. Then what do you think? Is PA continuous? Is it a continuous function?
Continuous function. R is continuous because of it.
No, what is TA? What is TA? TA.
Linear function.
Yeah, is it
Now
continuous?
it is continuous.
Yes, it is a continuous function. And that happens because what is TA of X? It's just multiplication by this matrix Eij to the vector x1, x2, xn.
Yes, sir.
Which is nothing but the first column is sigma A1I xi. I goes from 1 to n and so on. And the last column is ANI. I goes from 1 to 1 xi.
Summation of continuous functions.
Right. So when I look at T of xi, then the point is that each of its coordinate is a continuous function, because each coordinate is nothing but multiplication is sum of a constant multiplying a variable. The identity function. Therefore, each column is a linear combination of continuous functions, hence continuous. And because each component is a continuous function, the whole function has to be continuous. So this is a continuous function. The next function I want to assign a matrix A is a real valued function. Let me call this function SA. It has a name. It's called as So this is called as the quadratic form associated with A. Following is the definition. SA, when it acts on a vector x, then it is equal to inner product of x with AX. So we already know the formula for AX is this. So we know that this is a formula for inner product AX. Therefore, this is nothing but sum of x1, x2, xn. And see that this is a real number, because inner product takes values in R, rather non-zero real numbers, non-negative real numbers, times this. And what is the inner product then? This components multiplies this component plus the second components multiplies second component plus the last component multiplies the last component. Therefore, the eventual formula is that xj
corresponding product.
Yeah. X I aij xj. Sum is taken over all possible ij's. So that's SA of a vector xj. See, now we know that x going to AX is continuous. right? And we also know that the inner product is continuous. Therefore, SA is automatically a continuous function, being a composite of two continuous functions. But SA also takes values in real numbers. Therefore, in fact, SA and as well as TA both are differentiable as functions of multivariables. So yeah, this is what is defined. And then with these two definitions in mind, let me state the first theorem, which says that let V1 be the unit ball in V. It's a collection of all vectors whose norm is 1. What is norm? It's square root of inner product of X with itself. This is nothing but the unit ball in V. You can identify it as Rn. Then notice that, a side remark, V1 is bounded by definition and it's closed. You find out why is it closed. It's because the norm function is continuous. So this is a unit ball in Rn. Then the function SA, the quadratic form associated with A, attains a maximum value at a vector, at some vector Z. And Z is an eigenvector. So in fact, the theorem tells us that, see, attaining maximum value, as you will see, is easy. But the interesting part is that this turns out to be the eigenvector of E. That takes some effort. Can you tell me why is the maximum attained now? In fact, it's clear in the way we have discussed things. Can you tell me why is maximum value attained for SA? So I think of SA as a function from the unit ball to R. I'll say that the maximum value as well as the minimum value is attained. The maximum and minimum values are attained. I'll show you a hint. Can you see it? Hello?
Yes, sir. Yes, sir. The screen is.
Yeah. Okay. Sorry.
Anyone from participants, why it is
Can you
maximum
see
minimum
why?
attains?
Is SA continuous? Hello?
Yes, sir. Continuous,
Yeah, we
and
just
that's why it is continuous and bounded.
right. So SA is a continuous function, and V, as we already noticed, is a bounded and closed subset. It's the Heim-Borel property in Rn.
Yes, sir.
Therefore, when seen as a function on this subset, its maximum value is attained and its minimum values are also obtained, but we forget the minimum value for a time being. Therefore, so let Z be the vector such that if I take SA of Z, then this is the maximum value that, is less than or equal to SA of X for all X in the unit ball. So yeah, the first part is clear. It's pretty much clear from the earlier theorem. Now we want to show that this is an eigenvector, which means that if I take A, apply it on Z, then this is equal to lambda Z for some lambda in R. And note that Z is a unit vector, so it's not zero vector. Good. So to do this, look at SA in a product X. SA at X. This is a differentiable function also. But now what I'll do is do a trick. This is basically a function on a subset of Rn. I'll convert this into a function from R to R. And how do I do it is as follows. So consider this as R n space, n-dimensional space. And V1 is nothing but the unit sphere. So this is V1. It's a collection of all unit vectors. Now here there is a vector which we called as Z, at which the maximum of SA is obtained. The maximum of the quadratic form is obtained. Now I'll look at the perp of Z. The perp of Z is going to be the n-1 dimensional plane passing through origin, and it's perpendicular to Z.
Z vector.
Right. And from this perp, I choose a vector W.
It must be in plane.
Yeah. Okay. So what you do is choose a unit vector W from this n-1 dimensional space. So its norm is 1. Because its norm is 1, it's going to lie on V1. It's going to lie on the unit circle. Right? Good. So once I choose this W, it's any unit vector. Any unit vector in this plane. The next thing is I look at the circle which passes through W and Z. Okay, just the circle, one-dimensional circle. So it's a circle which passes through W and Z. And now, if I just call it as S, then the function SA, when restricted to the circle S, two real numbers, S is in some sense one-dimensional, is the required function. But we do it in a trick. What is equation of such a circle? It will follow from plane geometry. So in general, if I have two vectors E1 and E2 in R2, what is the equation of the circle? It's nothing but cos t E1 plus sin t E2. Replicate the same formula. Therefore, define this curve called P alpha is equal to Z times cos alpha plus W bar times sin alpha. And this exactly will be the circle where alpha is in R. And what is P of 0? P of 0 is alpha 0. So sin 0 is 0. Therefore, this is Z. And what is P of pi by 2? That's cos of pi by 2 0. Therefore, sin of pi by 2 is 1. Therefore, this is W. So this also says that as alpha ranges over R, as alpha goes from left to right in R, this circle goes from Z to W. It is a directed circle from Z to W. Good. Now on this particular circle, what is the quadratic form SA? If I apply it on a vector on this circle, then this is nothing but inner product of P alpha with A acting on P alpha. This is given coordinate wise. This is some coordinate wise. So here is a small exercise. Write down the formula for coordinates and show that if I think alpha as the parameter, so this is a function from R to R. And if I take the derivative of this function as composed P at alpha, then its derivative is by product rule. See, this is in some sense product. This is nothing but P alpha transpose dot product with A P alpha. This will be a coordinate wise product and their sum. So the product rule will apply to give me P alpha. Inner product with A is just fixed matrix constant. The variable is happening in P alpha. Therefore, this is just P prime alpha plus P prime alpha times A P alpha. So this is a small exercise for you to do. Good. But now the interesting thing is that I can take this A to the left. A is a symmetric matrix. Therefore, the first term is nothing but A P alpha. That's where we use the symmetry of A times P prime alpha. And the second term, because the inner product is, it's a real inner product. Therefore, I can flip this two terms. This is same as AP alpha times P prime alpha. This is nothing but 2 times AP alpha P prime alpha. That's it. That's the derivative. So we have a formula for SAP alpha. Good. But we know that this function takes maximum value at 0 by the earlier geometry and arguments which we had. Therefore, this derivative at 0 must be 0. Because that's an extremum. But then what would be the derivative? It's A, P at 0, P prime at 0. Let's see, what is A, P of 0? It's nothing but A, recall P. P is this. Is nothing but alpha is 0, so this is Z. And what is P prime of 0? So P prime of alpha
W.
is in general, right? P prime is nothing but derivative differentiating cos and sine. So this is minus Z sine alpha plus W cos alpha. Therefore, P prime at 0 is nothing but W. So we have two values. Therefore, what we get is 0 is equal to AZ times W. And this happens for all W's in the perp of Z and which have unit length. In particular, if I take any W prime in Z perp, the n-1 dimensional plane, assume it's not 0. Then W prime upon its length is a unit vector. So this formula holds there. Therefore, what do I get there? 0 is nothing but AZ times W prime upon the length of W prime. But then this is nothing but, I can take this W prime outside to the 0, and this is W times AZ. So in general, this argument will tell me that geometrically, any W prime in Z perp is perpendicular to AZ, right? Which means that AZ, so I started with Z. I looked at n-1 dimensional plane perpendicular to it. Then I look at AZ, and AZ is a vector such that everything in this plane is perpendicular to AZ. Therefore, AZ must be in the line which goes through Z. Hence, AZ must be a scalar multiple of Z. It's a beautiful geometric argument. Hence,
Nice, sir.
so this proves that Z is an eigenvector. So that's the interesting and non-trivial part of the theorem. And then we go to the last part of the theorem. I'll call it as theorem 2. Take an n by n symmetric matrix. Then, if I consider this as a function from an n-dimensional space V to V, so then V has an, I'll write it in ortho, it's a very interesting part. So I'll write it as highlighting, it's a orthonormal. What is orthonormal? Orthonormal basis. It's a basis in which each vector is a unit vector and any two vectors are perpendicular, which consists of the eigenvalues of A. The proof is by induction. Start the induction at n is equal to 1. Induction on dimension of V. That means V is one-dimensional. It's an exercise. Check that the proof is easy in this case. In fact, in one-dimensional case, every operator is diagonalizable. Every operator is basically a scaling operator. Check it. So prove that if T from R to R is linear, then T of X is nothing but,
Sorry to disturb, but we have 5 minutes left.
Yeah, sure. I'll just finish it in 5 minutes.
Thank you.
Okay. For some lambda in R. Okay. So prove this fact. It's easy one. Assume for n minus 1. So assume that the theorem holds for n minus 1. Then at the nth level, consider this TA from an n-dimensional space to itself. By the earlier theorem, there is a vector Z in V1, which is an eigenvector. Okay. Now what you do is look at Z perp. Z perp is an n minus 1 dimensional subspace. It's the n minus 1 dimensional hyperplane to Z. The point is that the matrix is symmetric implies that if I take this function TA and restrict it to Z perp, then it's a function from Z perp to Z perp. That's what the formula says. I'm running out of the time, so I won't discuss the philosophy of this, but then look at the definition of symmetric matrix. The definition will tell you this geometry. It's a joy to see what this geometry is. And because it's a well-defined operator here, and this is an n minus 1 dimensional subspace, by induction, it has a basis W1, W2, Wn minus 1, which is orthonormal. And each of this basis element is an eigenvector. Now take this basis W1, W2, Wn minus 1 and add the vector z. By the earlier construction, the vector z is perpendicular and it's also an eigenvector. Therefore, this becomes your basis. So z is the earlier vector, and then you have W1, W2, Wn minus 1 in the downstairs plane. So this says that every such operator is diagonalizable. Every such matrix is diagonalizable. Yeah. So that's where we stop.
Very nice, sir. Thank you.
Thank you. So I have 3 minutes, right?
Yes, sir.
Can I
Yes.
use-
Yes,
can I
sir.
use
Yes.
3 minutes? Okay,
Yes,
good.
yes, yes.
Yeah, sure. Then I'll look at an application of this. See, consider xt as n many tuples of differentiable functions. So xi are differentiable functions. And look at this system of differential equations. D by dt of xt is A times xt. Assume that the matrix A is symmetric. So this is a system of linear equations. Then this theorem will say that A is diagonalizable, which means that A can be written as some matrix C, some matrix Z times C inverse, such that Z is a diagonal matrix. Therefore, in an appropriate coordinate change, I can take this xt to be x prime of t after coordinate change, and the system of equation becomes a diagonal matrix lambda 1, lambda 2, lambda n, where these are the eigenvalues times x prime t. But what does this mean? This just means that the system is dxi of t dt is equal to lambda I times xi of t. And we know solutions of this system are given by the definition of exponential function. So this will just say that each xi of t is e raised to lambda it. This is the unique solution of the system up to a scalar. So it's a nice application of this earlier theorem for solving linear equations, differential equations. Yeah, so I'll just stop now. Thank you.
Thank you, sir.
Any questions?
Yeah. Our next, I'm very much thankful to Dr. Rohit Holkar sir for delivering a very nice speech on basically on linear algebra and presenting its applications as well. Thank you so much once again.
Yeah, thank you for the invitation.
Welcome, sir.
Our next resource person is Dr. Haribhau Bhapkar sir, who will be delivering talk on a pragmatic approach of mathematics in pandemic COVID-19. I will be happy to introduce my friend and today's resource person, Dr. Haribhau Bhapkar sir, who used to be my PhD colleague as well. Sir, you have completed MSc, you are also SET qualified and PhD in mathematics. Your special achievements are you are BOS member of Engineering Sciences of MIT Art, Design and Technical University, Pune. You are also a BOS member of Mathematics of Modern College of Arts, Commerce and Science, Pune. You are the pioneering member of CGPA to Percentage Conversion Committee of Maharashtra State. You are also a PhD guide in mathematics and 5 students are registered under you. You have achieved Best Teacher Award in 2019 and 2020. You are currently working as a professor in mathematics of MIT Art Design and Technical University, MIT School of Engineering. You are also given talks, interesting talks on G24, TV Max, radio, TechWhip regarding this COVID-19 situation and role of mathematics in this COVID-19 situation. You have written, you are author of vast number of books, 156 books were authored or co-authored, which are useful for Pune University as well as universities in Gujarat, Mumbai, so on and so forth. You have published 40 research papers and copyright registered are 22. You are also either published or filed 26 patents. You have a large experience of 22 years of teaching, and you are editor or a reviewer of 10 research journals. You are member of 7 members of professional bodies. With this very brief introduction of Dr. Haribabu Bhapkar, may I hand over the controls of this meeting to Dr. Haribabu Bhapkar and request him to present his talk. Over to Dr. Haribabu Bhapkar. Thank you, sir.
Okay. Good morning, sir. Am I audible properly?
Yes.
Okay. Thank you. Thank you, sir, for such type of nice introduction. Good afternoon to one and all. And first of all, I would like to wish you very happy National Mathematics Day. I think all of you know that mathematics is a universally accepted language in the world. There is only one language which is universally accepted, and that is mathematics. Mathematics has its own special importance. So, dear all, I welcome you all to the third session of one-day national workshop on applied mathematics and career opportunities in mathematics on the occasion of National Mathematics Day. Title of my presentation is A Pragmatic Approach of Mathematics in Pandemic. Here, I have tried to express any virus graph in terms of graph theory, in terms of some bipartite graphs. And by using operations of a graph, I have defined different growth rates of pandemic. Okay, all are in terms of graph. This is my first work. And in this session, I will shed some light on this work only. But my another work is to measure severity of any pandemic. We have two main formulae. First one is recovery rate and second one is mortality rate of that pandemic. Dear all, the existing formulae given by WHO to measure severity of pandemic are not so much accurate. There is less accuracy. So that means there is a one gap between this, and that gap is, suppose few patients are admitted yesterday, day before yesterday. Actually, to recover patient of COVID, we need at least 14 days. So how can we consider cases which are admitted today morning, yesterday, day before yesterday? So I consider recovery time period, and accordingly I have defined two new formulae known as progressive recovery rate and progressive mortality rate. These are published in the Journal of Medical System, which is at USA, and we have received copyright of the same from Government of India. And these are unique formulae which consider recovery time period. And recently I have given presentation to our scientists of ICMR, which are related to epidemiology, and I'm trying to give presentation to WHO because these are unique formulae, and we will be happy to present this formulae to the world. Now let us come to our our topic. Dear all, depending upon mathematical predictions and their interpretations, most of the countries have locked down and controlling the spread of COVID-19 pandemic and saving life of the people. I think everyone aware that there is a lot of comparison between this pandemic and Second World War. Now, what is a common thing between these two? It is interesting to note that mathematics has been playing big role, great role, not only in that World War II and pandemic situations, but also every real life problem. I think in World War II, code breaker led by mathematician Alan Turing helped shorten the war by 2 years. And in a similar fashion, mathematics has been helping in our battle against COVID-19 pandemic. Okay, so dear students, I have tried to express virus graph in terms of graph theory, and this is my first work of COVID. So I will introduce some brief introduction of that mathematical modeling. So model means miniature representation of something, just like cartoons in newspaper. Yeah, some if we express something in terms of mathematical equations, so that will become mathematical model. Why mathematical modeling? Because mathematics is a one precise language, that is concise language, and all the results that mathematicians have proved over hundreds of years are known to us, and computer can understand only mathematics language. So that's why mathematical modeling is important, and techniques of mathematical modeling is suppose we have some real life problem, then try to match our real life difficulty problem to existing model. Refine that existing model according to our problem, convert it into mathematical equations, means mathematical model, by defining equations, then defining variable, constant, parameters, then applying desired theory of mathematics, whether trigonometric, yeah, graph theory, yeah, set theory, yeah, differential calculus, integral calculus, transforms, that depends upon nature of the problem. Then solve this problem, mathematical model, by that depends upon your mathematical expertise, and then find conclusion and interpret conclusion according to the real life problem. That means, analogically, we can say that catch hold of some real life problem in your teeth or mouth and jump into mathematical ocean, swim there for a while, add desired flavors of mathematical theories, some tools, and come out to the surface with a beautiful and innovative solution of your problem. And nowadays, this is known as design thinking in mathematics. Design thinking is not different from this. In mathematics, the design thinking means mathematical modeling. Now, next one is virus graph through graph theory. So to define any graph, what we required some vertices and edges. Suppose graph means, suppose here we have a 3 points and join edges like this. So this is the one example of a graph. Simple graph means which is free from loops and parallel edges. That means there is no such type of loop. This one is a loop, and parallel edges means this graph. So graph without loops and parallel edges is known as a simple graph. Null graph means there is no any edge, we have only vertices. Cycle graph is like this. Suppose degree of each vertex is 2, and that is a connector. So this one is a C4. And star graph is just like its name. Its representation is, here we have a one center point and join this with null vertices like this. So this one is a star graph. This one is K15. Next one is partite graph. So how to define partite graph? Partite means use partitions. So how to use partitions? Suppose divide vertex set. Phi of H is a vertex set. Divide vertex set into n disjoint subset such that union of all these subsets is original vertex set. And all these are disjoint. And every edge of H joins a vertex of Vi and vertex of Vj for I is not equal to j. And depending upon this number of partitions, there are different types of graph. First one is bipartite. That means here n is 2. Tripartite means n is 3. There are 3 partitions. And four-partite graph means there are 4 partitions. So bipartite means one example is suppose here we have this graph. One partition is this. Suppose this one is V1, which involves 2 vertices, and another one is suppose this one is V2. There is no edge between vertices of V1. One end of edge must be in one set and another must be in another set, like this. Now next one is cut set. This is an old philosophy in graph theory. Now recently we are using this same philosophy to prevent spread of COVID-19. So how we are using? So let us first understand what do we mean by disconnecting set. Disconnecting set is a set of edges of a connected graph H whose removal disconnects H is called a disconnecting set. Okay, and the smallest disconnecting set is called a cut set of H. Suppose this one is a one graph and the smallest is this, so cut this, so this will get disconnected, so this one is a cut set. Next one is corona products. Now all we are facing so many problems due to this COVID-19 means coronavirus. This corona name, corona graph, this name is given by French and Harari in 1970. The corona product of H and K is denoted by H square small square K and obtained by a copy of one graph H and cardinality of phi of H, copies of K. That means suppose H has 5 vertices, then take 5 copies of K and joining each vertex of H to all vertices of graph K. Suppose H is C4 and K is this graph. So take one copy of H and how many vertices are there in H? 4 vertices. So take 4 copies of K and join each vertex of H to all vertices of K, like this. Here we join one vertex of H to all vertices of P of K. Then similarly join these two like this. So this is the corona product of H with K. This one is not symmetric. By definition also you realize this. Now variable set. We know that set is collection of well-defined objects and in which number of elements are fixed. Suppose we are talking about a set of first 10 natural numbers, then cardinality of that set is 10. Elements are also fixed. So how to define variable set? So a set S is said to be a variable set if elements of S changes with respect to time or according to some rule. Elements are not fixed. For example, set of active COVID-19 cases in India. Okay, set of total infected cases in India, like this. So this cardinality is not constant. Cardinality changes or constant for particular, but elements are changing. If cardinality is constant, then we replace elements. According to the seniority of cardinality of set, there are 5 types of variable set. I think all mathematics student know this, what is increasing set, decreasing set, non-increasing, non-decreasing. So accordingly define this. If x is strictly less than y, then cardinality of s of x is strictly less than s of y. This is increasing. Then decreasing set means variables are increases and cardinality decreases. Non-decreasing means x is less equal y and cardinality is also less equal. We introduce equality here. And non-increasing means x is increasing and this one is equal to or decreasing. And here we have introduced one important concept, stable variable set. This table is used to denote cardinality. Cardinality is constant. Okay, variables are changing. Cardinality is constant. For example, number of telephone towers in Pune district. These are constant, but mobile connections are changes. Okay, this is the example of stable variable set. Now, by using this defined variable graph, a graph in which v of h or e of h are variable sets is known as variable graph. Sometimes we call this as a V graph. This V stands for variable. Big network graphs are variable graphs. Mobile towers, mobile connection, all that are variable graphs. Then infected cases that are variable sets. So we can define variable graph on that. So there are two types of variable graphs. First one is age variable graph. That means E of h is variable. Vertex set is stable. Number of vertices are same. Number of vertices are same. Edges can change. So this is age V graph, and age vertex V graph means number of vertices. Vertex set is variable set and age set is constant. Okay. Now, n-partite variable graph. Just like same, we have defined partite graph. So apply same logic to define this one. So here, bipartite V graph means variable graph means if n is 2. Tripartite means n is 3, like this. Active and passive elements. In bipartite variable graph, a vertex x of V1. We are considering bipartite graph. So there are two sets, V1 and V2, whose union is vertex set of that graph. So x belongs to V1 is said to be active element if there exists a bond between x and at least one element of V2. Suppose this one is a one set, this one is another set. So this one is x, this set is V1, this one is V2. If there exists at least one bond between x in V1 and another vertex of V2, then we call this as active element. Or in another way, in more pragmatic way, x is trying to build bond or edges to the vertices of V2. At present, there is no bond, but this one is trying to build a bond between vertices of other sets. Okay. Now, passive vertices means which are not active. And similarly for second set. That means we can define active and passive vertices of two partitions, V1 as well as V2. Now, depending upon these partitions, there are four types of virus graphs. First one is a bipartite graph is said to be a virus graph 1 VRG1 if. Now see here, I have connected any pandemic situation through graph theory. That means here one partition is I. V of h means vertex set of h. So this is equal to I union n. Now I means variable set of vertices have some special properties or infected by virus. I is set of infected cases. And N means N be the variable set of vertices which are not infected by any virus. That means no some additional features. This is with additional features and this one is not having additional features. So this one is, suppose I means set of infected cases and N means non-infected cases. So there are only two partitions, either infected or not infected. X belongs to I creates a bond or edge with the vertex Y belongs to N or vice versa. Then Y is shifted to I. So N will become N is equal to N minus Y. Now why we are using this? Because this N is not fixed. N is a variable set. So at one instant, N is equal to suppose 1, 2, 3, and 4. And after that, N will become suppose remove 4 and add suppose 6 and 7. So this will become 1, 2, 3, 6, 7. So notations are same because this one is not fixed notation. That's why we write N is equal to N minus Y. Just like we write this as infinity is equal to infinity plus suppose 5. Yeah, infinity minus 5. What is infinity? Infinity is a symbol of big number. Okay, infinity is a symbol of big number. That means infinity is a variable which is used to denote big number. Similarly, this N is a variable which is used to denote variable sets. Now, if I belong, X belongs to I is recovered by treatment or lost property of virus, then X is shifted to N. So in that case, N is equal to N union X, like this. So here we have only two partitions, infected and non-infected. Non-infected may infect and infected may recover and shifted to N. So here we have a situation of bipartite graph. So by using this, I denote this by virus graph. For example, suppose you are suffering from cold and cough, then you are infected for 4 or 5 days, and again after recovering, you will be shifted to non-infected, like this. Virus graph 2. It is a tripartite graph in which I and N are same as that of previous, and F is a different. F is the set of vertices which can never be shifted to I or N. That means F is infected once is infected forever, like this. Okay, F means set of vertices which will not be cured by that disease. So here these remaining conditions are same, and last one is vertices of I are shifted to F if the vertices are infected forever. If cases are infected forever, therefore F is non-decreasing variable set. That's why I have defined that types of sets. Here F is non-decreasing variable set, either same cardinality or increases. That means, for example, suppose here is cases infected by COVID. This one is non-infected, and this one is infected. And who will be die in near future? Yeah, death cases. We may consider death cases here. Infected once is infected forever. This is the philosophy. And here, dear all, observe this thing, all we are in this stage, virus graph 2. Because at present, we have a one set of people which is non-infected, one set is infected, another set is death cases. Okay, there is no third possibility here. For polio, there are different possibilities. Now, for polio, we get vaccine at early age, so that means there is a one set. Suppose this is a shield of polio vaccine. Here we have infected, non-infected by polio, here infected by polio, and at early age, death due to polio, like this. So we need to add, pragmatically, we need to add one more set here, and that leads to third definition of virus graph, that is known as virus graph 3. That means here INS. So S is set of vertices which is never infected by virus after getting vaccine, polio vaccine. Okay. So here observe one thing, I and N are same. Actually, we are waiting for this situation. We are waiting for permanent vaccine. After getting that vaccine, we should not be get infected like this. So situation is like this. This one is a sealed additional feature. So vertices of N with some additional features can be shifted to variable set S. Furthermore, the vertices of S are protected with shield of antivirus or some special vaccines like this. Okay, the vertices of I can't be directly transformed to S, but transformed to N and again N to S. So S is non-decreasing variable set. So this is the case of polio. And one more thing is, fourth one is, now add all cases together. I means infected, S means non-infected, S means protected with some shield, and F means infected once is infected forever. So this virus graph is a 4-partite virus graph in which vertex set is equal to I union N union S union F, and conditions are like this. And last one is vertices F can be never shifted to any other set, because F means infected once is infected forever. This is the meaning of F. Infected by polio is infected forever. Okay, so there are so many such type of situations in real life where we require these 4 groups. So its diagrammatic representation is like this. Now what is a virus graph? We have defined virus graph 1, 2, 3, and so on. So here virus graph is a variable graph is said to be a virus graph if it belongs to class of either virus graph 1, 2, 3, or 4. Okay. Now how to define growth rate? The growth rate of any V graph is a rate of increase of active element minus the rate of increase of passive element. There are 3 types of growth of any virus graph according to graph theory. What graph theory is suggesting us? There is a 1-to-1 growth. Dear students, I have explained one definition, that is a corona product of 2 graphs. And beautiful part of that definition is, because don't consider definition exactly according to the meaning. Use that same philosophy in real life. Define something analogically. So that will help you to develop your own application of any mathematical topic. So dear students, here the growth rate is said to be 1-to-1. If one active element of a variable set infects only one active element of other set, that's why 1-to-1. All of you know what do you mean by 1-to-1 function. Same thing is here. This set is I, infected set, and these are, suppose here we have a 5 active elements of I. These are 5 active elements. The rest of the elements are passive elements. So this one active element infects one active element of non-infected set. So this growth rate is known as one-to-one growth rate. There are so many diseases for which there is one-to-one growth is there. Second one. Now, for this one-to-one growth rate, suppose growth rate is constant, then what will happen? So how to construct mathematical model? So without loss of generality, assume that there are 30% active element in each set. And also assume that the number of infected people is extremely less than the total population. If this growth type, every day 30% new patients are increased in the set. And suppose I not be the number of people infected by virus at initial stage, at t is equal to 0. This one is I naught. And in be the number of people will be infected after n days. So its mathematical model is after 1 day, first infected plus 30% growth. So 0.30 of I naught, that will become 1.3 into I naught. I2 will give 1.3 square I naught, and in general, In is this. Okay, but while designing this mathematical formula, here we have a few assumptions. Second one is, suppose R be the growth rate in general. In previous one, now for research, there are two methods. First one is generic to particular case, and second one is particular to generic case. So first, I have explained particular case, 30% active elements. So here generic case is this. Suppose growth rate is R, then I1 is equal to I naught plus R times I naught. So take I naught common, 1 plus R into I naught. So I2 will become 1 I1 plus R times I1. So 1 plus R whole square into I naught, because I1 is this. And in general, this one is. Now this is for first case, if growth rate is constant. Now suppose growth rate is not constant. Suppose for 5 days that growth rate is 20%. Then again, for next 5 days, if that will become 4%, 10%, like this. Suppose that growth rates are R1, R2, R3, and Rn. And at time, these are, suppose these are, we may consider these as days, suppose first 5 days, then next 5 days, like this. So I1 is equal to I naught plus R1 times I naught. And this will gives, this is equal to 1 plus R1 I naught. After second time interval, this will become I2 is equal to I1 plus R2 times I1. And this will become, in general, In is equal to 1 plus R suffix n and product of 2 into 1 plus R2 into 1 plus R1 into I naught. Okay. Now, actually, I have that table, but due to time limit, I will not show you that table. Now, second growth type, 1 to P. P means P number of vertices. One active element of a variable set, that is I means infected cases, infects at most P active elements of other set, means non-infected. Together at that instant is called 1 to P growth. In this case, CM is a cycle graph having R active elements of variable set I. So its pictorial representation is this. Suppose this is I, and these are active elements of I. So this one element infects at a time P elements of other set. That means this is a case of our recent pandemic COVID-19. Okay. one active case, one active element infects at most P elements at a time. But what about P? Is there any limitation for P? So, and what is this? This one is a corona product of cycle graph with null graph. Okay, and we are facing same situation right now. In wave 1, wave 2, we are doing same. And here interesting part is what will be the limits for this P. So 1-to-1 case is first, so P must be strictly greater or equal to. But what will be the upper bound for P? So upper bound of P is, now here assume that there are R active elements in a set. R% new patients are increased every day in the set. So here I not be the number of people infected by virus at initial stage. And IN be the number of people will be infected after N days. So dear students, here I1 is equal to I0 plus R into P into I0. What is P? What is P here? Why we introduce this P? What is the meaning of P here? So this gives, take I0 common, this R is a rate. So rate means one active infects P elements at a time. Suppose that P is 4. So here is 4. Like this. So this will become 1 plus R star P star I0. So this gives I2 is equal to I1 plus R star P into I1. And put I1 is equal to this one. So this will become 1 plus R star P whole square into I0. And in general, we have this formula. And to get, nowadays we come across with new terminologies, rate of doubling, positivity rate, like this. So here I have put one assumption. How many days are required to double the active cases? Yet to double the infected cases. So number of infected people will be double in at most these days. Doubling rate is this. Okay. So put here value of R and P, we will get doubling rate of COVID. Yeah, any pandemic. So if R is equal to 1%, 0.01, N is equal to 2. Okay. And the greatest value of P is the value where I0 will become double. Okay. For this case, and this is my assumption. So by simplifying this, we get P is equal to, this is the approximate value of P. P is equal to 40. So in this growth type, P is less equal 42. Okay, and in first wave, I think P is equivalent to 3 or 4. In second case, second wave, P is equivalent to 6 to 8. And it is predicted that in third case, this P may be 10 to 12. Okay, now, is there any particular case of growth rate? Because if we are talking about mathematics, then there should be generic mathematical model. So here we have a 1/3 growth rate, that is 1 to all. All means, all stands for more than 42 at that instant. That means if one active element of a variable set infects all or more than 42 active elements of other set together at that instant. This is called one-to-all. That means one-to-all means community spread of COVID. Community spread. Okay, we call this as one-to-all. Now, such type of growth occur if the spread of virus is through water or air. Okay, through water or air. And this is extremely perilous for living beings. And by using corona product, how to define? This is a cycle graph. Active elements are here, non-active are inside, and one active element infects group of non-active cases together, and that cases are greater equal 42 at a time. So here we cover all cases of COVID, yeah, any pandemic in this growth rate, 1-to-1, 1-to-P, and 1-to-all. Next one is now analysis of COVID-19. COVID-19 is a virus graph. We have defined 4 virus graphs. Initially, it was in the type virus graph 1, means infected and non-infected. Okay, initially there was only 2 parts, either infected or non-infected. Phi of G and E of G are variable vertex set of people, and variable age set of the COVID-19 graph C. So vertex set of C is I union N at initial stage. I means infected cases, N means non-infected cases. And all these 2 are variable sets because some infected will be covered, so that will be transformed to non-infected like this. Now here, as I told you, why I have explained that disconnecting set, yeah, cut set. The chain of the graph can be disconnected by using philosophy of disconnecting set. For virus graph, to break the chain, so keep all vertices of either set in disconnecting set. That is, D is equal to set of all roots adjacent to each vertex of R. Suppose this one is an infected area, and here are some roots which joins to infected area. Block all these roots. Block this root, this root, this root. So disconnecting set of this root is like this. Second one is, or set of all root adjacent to each vertex of N. If this one is very, very big and non-infected is small, so protect that non-infected group. Instead of protecting infected group, protect non-infected group. That's why that minimum disconnecting set is known as the cut set. So moreover, the cut set of C is I. If I is less equal N, otherwise that will be N, cardinality of N. Now, at present, every country of the world is doing same philosophy for controlling the effect of COVID-19. Controlling the spread of COVID-19. Isolation. Suppose this one is infected case. So what we do? We isolate him. We quarantine him. So quarantine means like this, remove all bondings. So isolation means singleton. Keep all that patients in a one room, one hospital, at one place. So This quarantine philosophy is old philosophy, which is used in mathematics, that is cut set, disconnecting set. Then second one is presently. Now, what is the present situation of COVID-19? Presently, COVID-19 is in the virus graph 2. So what do you mean by virus graph? Infected, non-infected, and infected forever. Death cases is included here. Death cases. Okay, and dear all, we are eagerly waiting for third case. Third one is infected, non-infected, union S. S means protected with the shield of something. There is no death case. This is a third type. And whole world is eagerly waiting for this type of situation. Presently, we are at this stage. There is no set S in present because presently there is no fixed vaccine which protect us from infection of COVID-19. That is a booster dose. Presently, we are getting doses that are booster dose. Now, next one is growth type of COVID-19 is 1 to P type because person can infect, one person can infect at most P is less equal 42 persons at a time. And here I have made one table which predicts the infected cases, but these are under some assumptions, so I will not explain this. So dear students, how to study something, some concepts of mathematics, that is very, very important. I think all of you know that numbers never lie. After all, they simply tell different stories depending on perception of that particular person, that particular student. Okay, if you think differently, so how to think differently? What do you mean by different thinking? Just like this live case study, this COVID-19 and virus graph, bridge between one mathematics topic and real life application. This is a what we call this as a live example of design thinking in mathematics. And next one is design thinking of mathematics is there is a one more topic of mathematics which is very, very important. That is, I think all of you know this fuzzy set. Fuzzy set. This one is defined 1965. Rough sets. This one is defined around 70. And soft set. This was defined around 1999. Okay. So fusion of these three sets. How to use fusion of these three sets to buy a flat, to buy a house. How to use fusion of these three sets to decide a life partner. So here there are some theories which deals with vagueness, imprecise data. So I think now 79 participants are there. And if I ask you one simple question, how many of you understood this? So you can raise your hands and tell me, suppose that number is 50. Okay, very good, no problem. If I ask you one simple questions, how many of you can drive a car? There may be suppose 56 persons are there, 56 participants are there. If I ask you how many of you drive a car very well, then how to decide? We can decide. How many of you are clever? So this cleverness is imprecise statement. This is an imprecise knowledge. We can say that imprecise knowledge. And to deal with imprecise knowledge, we have a different theories, and that theories are fuzzy set theory, rough set theory, and soft set theory. And dear all, by using rough set theory, so for COVID-19, how to use rough set theory? This is very, very important. So to use this, we can follow one symptomatic prediction of COVID-19 cases. Symptomatic prediction means for COVID-19, there are 10 symptoms, and out of 10, remove independent symptoms. Okay, and try to reduce this set to 4 main symptoms only. So for such type of logic, rough set theory is used. And I have published one paper on rough set theory, and within 7-8 months got 23 citations of this paper. And for this graph theory and virus graph, I have received 20 citations. Okay, and for that my paper formulae of progressive recovery rate and progressive mortality rate, I received 24, 23 citations. So dear student, if you know mathematics, if you understand mathematics, then easily you can find a bridge between real life problems and mathematics. And if you mug up mathematics, then it is not possible to find bridges. And presently, whole world is working on basic things, basic science. They are using basic science, basic concepts of science, math,
Excuse me, sir.
physics, chemistry,
Doctor,
all.
sir. Excuse
Yeah,
me.
yeah.
How much time extra?
One minute.
Okay. Yes.
1 minute.
Thank you.
So presently, everyone is working on basic sciences and collaborating with different experts. So maths expert collaborate with experts in machine learning and artificial intelligence, because it is not possible to suppose me to learn machine learning in detail. I am expert in mathematics. So make collaborative group and do research, solve real life problems. And dear all, if you have any questions regarding this, you can call me anytime, send me WhatsApp message, send me mail. Nalawade sir will share with you all my details. And thank you very much for giving me an opportunity to share my views on pandemic. Thank you, sir. Over to Nalawade sir.
Manish.
Thank you, sir. You have given very nice introduction to graph theory, and using that you have shown how one can use that to deal with such pandemic situations. And thank you very much for such lovely introduction and lecture, sir. Now I will ask Mayur sir to introduce our next speaker.
Okay,
Thank you, sir.
good afternoon, everyone. माहित नाही काय प्रॉब्लेम आहे.
Doctor, sir, you
Okay.
start.
Yeah.
Okay. Good afternoon, everyone. So let me introduce our next speaker for today's session. So our next speaker for today's session is Dr. Mahesh Vawre, and he is associate professor at Rajashri Shahu Maharaj Vidyalay, Rajashri Shahu Maharaj Mahavidyalay, Latur. He has done his MSc in 2002 from Savitribai Phule Pune University, MPhil from MKU Madurai University in 2011, and PhD in 2000 2020 from Swami Ramananda Tirtha Marathwada University, Nanded. He has done his PhD in linear sections of Schauber's varieties and linear codes associated with Schauber's varieties. Also, he has received many awards from reputed agencies, and one of the highlighting award that he received is Young Research Award in 2021 from the Institute of Scholar, Bangalore. Also, he has published around 8 research papers in reputed journal, and he has authored around 13 books on mathematics and computer science in reputed journals, publications. Okay, so with this brief introduction, I request Dr. Vavre sir to start his session on this occasion.
Thank you, Mayor sir, for introduction.
Welcome.
First of all, I will wish everyone that happy Mathematics Day today. Happy National Mathematics Day.
To you, sir.
Respect, yeah. Respected Principal Dr. Mrs. T.D. Savade, Principal ESG Shinde Mahavidyalaya Paranda, respected Principal Professor R.G. Pardeshi, Ferguson College, Pune, the resource speaker and keynote speaker of today's morning session, and my guru, Professor S.A. Katre sir, Dr. R.D. Holkar sir. Just now you have listened the lecture of Dr. H.R. Babkar sir, the organizer of this workshop, Professor Manish Aglave sir, Vidyadhar Nalode sir, and IQAC coordinators of both the institutes. Can I share the screen?
Yes, sir.
Yes, sir, please.
So as since the morning, we have learned lots of mathematics here. So I want to just tell you that how the mathematics can change your life. That is an exciting career opportunity in mathematics. My introduction was given by Mr. Mayur Shirsagar sir. First of all, I will just share the general view of common people about mathematics. So what people think about mathematics? Mathematics is very hard. Mathematics is too boring subject. From childhood, we are hearing that quotes. Maths has nothing to do with real lives. Most of the arts faculty people or other engineering science stream people are saying that maths has nothing to do with real life. But I can show by 1 or 2 examples how mathematics is important. And in general college observations, since there are all the students, what students are thinking, all the mathematics professors are mad because they are just in their word always. They differentiate between other faculty teachers and mathematics teachers because of the overthinking this. So how mathematics is important, I will show you in the next example. So mathematics can be used in the forensic science course. Nowadays, many people are doing the forensic courses in which the mathematics is involved. So how maths and crime have relations? This is the blurring of a number plate. That blurred number plate can be removed as a correct number plate. So I shall say some short story about it. Some robber have robbed the bank, and once he got all the cash, he was escaping through some gate, and he ran from that gate. He ran away from that, and it was pursued by the police. Now there are 2 news. One is good news, and another is bad news. So what is good news? The police took the photo of that car. And what is the bad news? See, this has the blur image. He cannot judge even whose number plate is that. But now you might be thinking how mathematics is involved. So this blur image, you can sort out by using blurring formula. You can using the mathematical software, not only pure mathematics, but you can sort out this number plate in the next steps. So solution of these problems comes into mathematics. So the people have constructed, this is not my work. The people have constructed the model for this blurring process. So we required blurring functions. The original image is stored as function g in some software, and the blur image is h. And this is the blurring formula. Since here two variables are involved, x and y, so you have to understand this d2y as dx dy. And some inversion formula is applied to get rid of the blur. So I'll show you in the next slide. And this is your f actually. G you need to calculate. And by inversion formula, you get this as h of x, and the number plate can be directed correctly. So this is an example of image processing that can be used with the help of MATLAB software or Maple software or any other previous software also. You have to just go and search on these things, the mathematics application here. So forensic science people also mathematics used widely. You must heard about the Newton's law of cooling, in which the first order
Sir, you are not audible. Vaure sir. I hope his connection is problem. He will join. Hello, Mahesh sir. You are muted. Mahesh sir, Vaure sir, you are on mute. Mhm. सर तुम्ही म्यूट आहे महेश सर.
हा सर
हा,
मध्येच
ओके.
काय हँग झालं सिस्टीम
हा
माझं
हा
बहुतेक.
हा हा नाही नाही काही प्रॉब्लेम नाही sir.
कुठपर्यंत घेतलं होतं रे मी?
सर
Share
तुम्ही ते ब्लर इमेज दाखवली होती तिथपर्यंत दिसत होत.
ओके. ब्लर इमेज दाखवली तिथपर्यंत ठीक आहे. स्क्रीन दिसतंय का आता?
Yes, sir. हो दिसते सर.
ओके.
हा हा येथपर्यंत आलं.
Yeah. I was asking questions to students. You just post in the chat box that menti.com. In chat. I was trying to do that. And use this code. I want to answer from the student. What do you mean by career? Students are requested to just open this link and put this code. Whatever answer you have shared, what is the meaning of your career? What career means? Everybody thinking that I want to do career, but you should know what career exactly is. Or you can unmute and talk with me. Whatever is you responded from the website, that will come on here. Okay, I can show you later on this. Might be people are not responding. So, okay, some response has come. Somebody says that the career is money. Satisfaction, okay, very good answer. There are 84 people, I did respond. Okay, that can be followed. Somebody do something and getting followed by something. Like Ramanujan, you want to work. He also didn't work for money. He just worked for his satisfaction. And whatever the work he had done in his lifespan of 32 years, nowadays people are still working. So he makes careers of all. So that means the following, somebody can follow us. Sometimes you may not count in terms of money, but to have food, we need some sort of money. Not like politician, you have money, but something. Okay. For living, career is important, very good. To getting happiness, yeah, career also. If career, maybe you may get success or failure, but you should be happy with that. Career means dream, somebody right? Career means dream. Don't annotate on, okay. Future, okay, very good. You might not be knowing how to write on that. Okay, very good. So job that makes happy, that means satisfactions. So this satisfaction word, you can see this is bigger one, so that will be the response of many people. So they are thinking that the satisfaction means career. That is also a good answer. Okay, so let me stop this now. Okay, many answers are coming now. Career as a life, okay, very good. So can you unmute and speak, somebody? What do you mean by that the job makes you happy?
त्यांचं कनेक्शन रिसेट झालेलं दिसतं परत.
Okay, okay.
Sorry for the disturbance suddenly. Okay, I'll just share the PPT only. So we were discussing what is career. So let me explain that in mathematical point of view. What do we mean by the career? The career is defined as a sequence and variety of occupations. Sometimes somebody says that satisfaction, somebody says that money. You have to think what is career, either it is paid or unpaid, and which can one take throughout its lifetime. There are many more definitions about career. And the career is also defined as a program, whatever program you choose and what action plans you are taken by the person throughout the lifetime. But choosing the correct problem is also one problem. And also one can say career describes the individual journey through the learning, work, and other aspects of life. Now, next, when we choose career, most of the people, what you do after 12th science, just choose BSc as a course. They didn't have anything in mind to go to third year class, go to MSc also. They're not thinking anymore. Over 10 to 20% people are more focused about career, and they plans their career according to that. But there are 30 to 40% students who does not have any plan. Just they are waiting for 2 days to come and complete the degree, and then they are thinking what we have to do. So how to choose career? We have to plan the career. The career planning is a deliberate process of knowing who you are. आपण स्वतः कोण आहात, who you are, so that we can be sure where we want to go. And once you decided where we want to go, then what we want to be at certain point.
It is disconnecting, sir, again and again.
Yeah, I will call him. I'm calling him. Just wait for a minute. He will be definitely joining. Yes, he has joined.
Yeah, I'm actually, what is happening? What I do, sir, give me 5 minutes so that I can restart the system and join, because since from the morning, same problem happens. Or should I continue like that?
Continue, sir.
I will just share the screen. So in the earlier slide, I just explained what do you mean by career, and these are the steps involved. How to choose career? One should have a plan about career. What is career development? I told It is a process of managing of the life. The self-assessment is important. While this is the first important step in career development, how one should develop the career. You have to do self-assessment. Not somebody is telling that do that and all. What you have inside you, you decide self-assessment and make a career in that. Then career exploration in this, what will happen? Suppose somebody have decided to do MSc in physics, and some third party person will come and no, the statistics course have lots of demand. Then don't get influenced by anything. What you are interested, just explore on that. Whatever you are doing at the right point, which institute we have to choose, where we have to do the decision making is also important, and what the last important step is the taking action against on the given roadmap. So okay, I'm not wasting much more time in all those things. This lecture is particularly means to what the students can do after UG mathematics. Besides teachings, coachings, there are many more opportunities that I'm going to share with you. So I just career point of view, I just a few what is career and how one can choose career and how one can develop the self career. Now you be firm that whatever I am telling, what career you have decided, you don't change your mindset. I'm just informing that what you can do after your UG or PG mathematics, what opportunities you have. So those people who didn't focus on particular career, that 30 to 40% people, mostly 20% people are focused about their career and they are working on that. So don't change your mind after this lecture. So as is many people know that teaching is one of the professions for the mathematics students that you all well know. The competitive examinations also, you know very well what type of competitive examinations are there. Now, besides that, we want to do higher studies after your graduations. You want to do research in India or outside India, how to go for it. All those things matters. And beside all those things, one can do career in IT sector or some teaching industry.
Sir, again disconnected.
Dear participants, I have just called Dr. MS Bhavre sir that he will be restarting his PC so that it will boost in a better way and he can start his presentation from the point where he has stopped. Let us hope that in the remaining time we'll get more about career opportunities in mathematics. So let's wait for him to restart his PC. He will be definitely joining. So let's wait for just one or a couple of minutes.
I joined from phone now. Let the system get restarted. From phone, where to share document? Okay. स्क्रीन दिसतंय सर्वांना?
नाही दिसत आहे सर अजून.
शेअर तर केली मी.
थोडा वेळ घेत असेल. एक सेकंड.
वावरे सरांना व्हिडिओ ऑन करायला सांगा त्यांचं, कदाचित तो बंद होत असेल.
सर तुम्ही एकदा परत ट्राय करा स्क्रीन शेअरिंगचा.
ठीक आहे. दिसतंय का?
हा येस सर दिसतंय. तुम्ही आडवा ठेवता का सर फोन? हॉरिझॉन्टल.
हॉरिझॉन्टल का? स्क्रीन रोटेट करावं लागेल म्हणजे.
हो. हा बरोबर आहे सर, दिसते आता व्यवस्थित.
ओके, तोपर्यंत लॅपटॉपवर पण जॉईन व्हायचा प्रयत्न करतो मी.
हो सर.
So to become a school teachers, you must. It was not slide, I think. Okay. In the teaching, we have three options. Either you can join as school teachers nowadays. There are plenty of CBSE schools in which you can have job opportunity. Some schools may offer without B.Ed also if your teaching skill is good. For that, you have to do special science and mathematics method. And particularly, you should select B.Ed in English medium with reputed colleges. Like St. Xavier College of Education give placement to abroad as a school teachers. There is 100% placement for this B.Ed. If you do your B.Ed in science mathematics from St. Xavier College of Education, Mumbai, will have opportunities abroad for working. And we have the many people sort career as a point of money, so you can go for that. You will become a college teacher like Nalode sir, Manish Aglavi sir, like me, by completing your NET set examinations or degree of research, that highest degree, that is PhD. To become a college teacher, they are known as nowadays assistant professors. And also some of my friends while doing MSc, they are doing MSc from IIT Mumbai, and at that time they are having huge package doing MSc. They are getting 8 to 10 lakh packages for private coaching. What coaching you need to do from 8, 9, 10th, 11th, 12th, that type of private tuitions. So they are hiring the students who are doing MSc from reputed institutes like IIT, NITs or Pune universities. So they are also pocket money you can earn while you learn. So these things I will explain you. I'll just focus a little bit on the competitive examination. not mathematics, any graduate can do MPSC, UPSC. In particular UPSC, there is the combined defense service. Those students having at the physics and mathematics at undergraduate level can do join for this CDS. CDS, there are three: Indian Navy, Indian Army, and Indian Air Force. You will get the exam comes twice in a year. Those who are appearing in the BSc third year, they can opt for this. There is age limit for that. According to age limit, you can opt for that. Then Staff Selection Commission, Indian Statistical Service, mostly in the district places, there is the statistical officer or data analyzer, which is filled by the Union Public Service Commission also. Once you have graduation with one of the optional subject as statistics, then you can become you can join that Indian Statistical Service. Indian Postal Service, Central Police Force, all these students might be knowing. I have to tell a new thing about it. So firstly, after graduations, don't go for job. You just do, this is my suggestion. Otherwise, you decide what you want. But once you do MSc, then you can go for job. So MSc, you can opt your MSc from reputed institutes like IITs, NITs, Chennai Mathematical Institutes, or some ISI, Indian Statistical Institute. There are 3 Indian Statistical Institutes in India. One is as Kolkata, another is in Bangalore, and one is in Delhi. So there are plenty of courses offering these ISI institutes like MSc in Quality Management Science, not mathematics, MSc in Quality Management Science, MTech in Cryptology and Security. The cyber security, in each police stations, there need the cyber security expert. And there many people are not doing such type of courses. So in cyber security or security purpose, the mathematics number theory part is involved. If you learn that elementary number theory from David Arburton, and if you are well enough good with number theory, that theory of congruences, all those things, you can be joined with the cyber security course. And they are offering plenty of money to do this. This is also one of the options to you. You can have MSc Computer Science from Indian Statistical Institutes. You have MA or Master of Maths, Master of Science in Maths, Master of Science in Operation Research, Master of Science in Data Science. All those courses offered by this. And while doing these courses from Indian Statistical Institutes, you get stipend. Once you do the postgraduate, there are 2 postgraduate diploma courses. Every year in the month of May, the advertise comes. Every year in the month of May, advertise comes. So I will start from my laptop now. Laptop is on. Let me stop share here.
Okay, sir. Okay.
सर मला होस्ट करा इकडनं आता. So from Indian Statistical Institutes, you will get stipend 3,000 for doing postgraduate diploma courses. For MSc, we will have 8,000 stipend, and when you do research, we'll have 25 to 31,000 per month. While doing your study, you can make this.
You cannot share your screen.
Can I share now?
Yes, sir.
Yes, your screen is visible.
Screen is visible to everyone.
Yes.
सर स्क्रीन विजिबल आहे का?
स्क्रीन विजिबल आहे सर.
Yes, sir. Very much. It's
आवाज येत आहे का माझा?
yes, sir. You are audible.
ओके, हा म्यूट झाला तुम्हाला. ठीक, ओके. So we were discussing from where we want to do MSc. If you want to do MSc from IIT, NIT, many of people preparing for joint admission test. That is joint admission test for a master course in IITs. That is called IIT JAM. This year notification comes and exam is in February first week. The plenty of students preparing for that. The students can opt any science course, MSc course from IIT. He or she can do integrated MSc PhD from IIT with the help of this valid JAM score. And you can see past cutoff of that marks from the corresponding websites. And the syllabus for the entrance is your just graduation mathematics. If you want to do MSc mathematics, if you want to do MSc statistics, if you want to do MSc in physics, if you want to do MSc in life sciences also, whatever subject. You cannot do MSc electronics from IITs. The particular subjects are available, and there are total 2,500 PG vacancies after graduation. 2,500 PG vacancies, not for mathematics. I'm telling about all subjects. So every year in the month of October, the notification of IIT JAM entrance comes, and we have to fill up online the application for that. And exam is in the month of February, and admission rounds comes from the month April and May, and the course starts from every year June. So the second year students might be doing in the next year. Now those who are applied, they might be preparing for that. After MSc, one can become DRDO scientist. After MSc, you must have more than 65% or 60% marks in particular subject. If you have MSc Physics, MSc Mathematics, MSc Chemistry, or other MS subjects, you can work as DRDO scientist. You can work as ISRO scientist also, but you have to go regularly check on all those websites. The following are the ISRO centers where we can search: the Vikram Sarabhai Space Research Center, this LPSC, ISAC, SAC, all those. These are the ISRO centers. Okay, these are the ISRO centers in India, and we can work as ISRO scientists. ISRO people work like a team. So in Pune University, there is IQA Center. Those who are having physics, they can work as research scholars after PG, or one can do MSc Physics from Pune University and then try some research project from this IUCAA. So how one can apply for this IUCAA? There is joint entrance screening test for this, and total 22 institutes from India are participating for this. Besides the IIT, there are another institutes like this IUCAA. And the academic year of this IUCAA begins in August every year. The those students who have to complete by August this following degree. This is the eligibility. So I think you can do only research from this IUCAA. But in addition to that, some final year talented students can do the summer research programs, and they will get rid of all those things to get admissions in such 22 participating institutes through this JEST. Another thing, after BSc, if you complete your MSc, you have the JRF fellowships near about 35,000 to do PhD for 3 years, and then we'll get SRF fellowship for that. And from reputed institute, once you qualified CSR net with JRF, we will grab this opportunity. Along with that, the National Board for Mathematics also conducts the PhD fellowships for after MSc Mathematics students. This is for MSc Mathematics students only. Those students who are in the MSc first year or who are in the second year can choose this NBHM PhD fellowship program. And those who are in the MSc first year, he will get a scholarship during his MSc course if he qualifies that NBHM exams. Every year the notification comes. IISCs, IITs, and TIFR conducts another type of entrance examinations. This year, just now, in the month of December, example has conducted, that is known as GS2 2022 to get admissions in the all TIFR centers. For ISC, you should have valid JAM score. You will get admission for that. Another in Reserve Bank of India, if you have BSc with economics as one of the optional subjects, BSc as one of the optional subject. Shraddha J. Shraddha.
அப்புறம் ஃபர்ஸ்ட் எம்எஸ்சில பாய்ஸ்ல சிவசூர்யா போடுங்க, கேர்ள்ஸ்ல வந்து யார போடுங்க.
Her mic is open.
Please mute your mic if.
Sir, continue.
Then screen this then, sir.
Oh.
Okay. So in RBI, as economical officers, in the Ferguson College itself or Pune University, some college having BSc with economics subject also. Economic statistics, mathematics is one of the best group. And in RBI, you can join as the economics. Various bankers are having research and development unit. In that also the mathematical finance or mathematical economics, in that field also we can work. CA, ICW course, MSc Mathematics people can do this ICW course, which is also equivalent to the Chartered Accountancy. In the recent, in the health, in the insurance, we have to decide some policies and all, so that will make by these actuarial officers. In this actuarial MS, you can do MSc in actuarial, MSc in actuarial science, and if you pass the exam of London Actuarial Society, then it will be equivalent to this ICW or CA, and in your firm or any industry requires those officers, that will have huge package. You just go and search how to become the actuarial officers, will get rid of this. Previously I have explained about the Indian Statistical Institutes. From Indian Statistical Institutes, what you can do, after 12 also we can do some BMaths course, BStats course, Bachelor of Science course, but at now here all are graduate students. So in the month of May, its notification comes and it conducts the separate entrance exam to get admission in Indian Statistical Institutes. There are 3 statistical institutes. One is in Delhi, another is in Kolkata, and third one is in Bangalore. So what courses we can do from this? You can do MSc Mathematics from this, MSc Statistics from there, MSc in Operational Research from there, MSc in Quality Management Science, even though you can do MSc in Library Science course also, Library Science and Information Systems. This also having huge demand in the future. You can do MTech in Cryptology and Security. This type of people's work
सर अजून एकदा डिस्कनेक्ट झाले.
थोडा वेळ द्यायचा आहे का सर त्यांना अजून?
मी विचारतो त्यांना फोन केलाय. Excuse me, I have called Dr. Mahesh Bhavre sir and asked him to share the PPT on our national webinar, national workshop group. I think unfortunately lots of differences are coming and it's already late. So I thought of sharing only the PPT on group, and I think we should stop
Okay.
here.
So,
Yes.
okay, I will continue with vote of thanks. I first thank all distinguished speakers, Professor S.A. Katre, Professor R.D. Holkar, Professor H.R. Bhavkar, and Professor Mahesh Bhavre to give such nice lectures on National Mathematics Day. Now, I would like to take this opportunity to thank Deccan Education Society, Ferguson College, Autonomous Pune, also Principal R.J. Pardeshi, all my colleagues from Mathematics Department, Ferguson College, Pune. Also, I would like to take this opportunity to thank Shikshan Maharshi Guruvarya R.G. Shinde Mahavidyalaya, Paranda, and Principal Dr. Mrs. Savale ma'am, my dear friend Vivi Nalode, Deshmukh sir, all the participants, those who participated in this one-day workshop, and all the helping hands that made this program success. I am thankful to all of you. The special efforts taken by Vivi Nalode, Dr. Vivi Nalode, to make this workshop possible. Thank you, sir. I wish all of you thank you.
Thank you, sir. Very nice.
Any other thing? Yeah.
पॉवर पॉइंट शेअर करतो सर ग्रुपमध्ये. काय आज
Yes.
प्रॉब्लेम मला काही कळलं नाही त्याचा.
हो हो हो. काय हरकत नाही सर.
No problem. No problem.
Okay, sir.
Deshmukh, you may